Good morning, everyone. I welcome all of you for these lightning talks. So today we have Yuto Horikawa from Japan. So he's going to present a talk on creating smooth surface models with elastic surface embedding.jl. Over to you, Yuto.
Okay, can I start? Okay. Good morning. Thank you to the JuliaCon organizers and all of the audience here. The topic of my talk is creating smooth surface models like this. Could you please pass this model to your neighbor after looking? I want everyone here to have a chance to view it. Okay, hi. Sorry. Hi, I'm Yuto Horikawa from Osaka, Japan. I'm a maintainer of the following Julia packages, and this talk is about the last package, Elastic Surface Embedding.jl. I like to create mathematical handicrafts, and that's one of my life work. Okay, let's start with the overview of the project. There are 4 steps to create a smooth surface model. First, divide the target surface into strips. And second, embed curved strips onto a flat plane. Step 3, cut out the embedded strips from a flat material such as paper. And the last step 4, weave the strips together and obtain a smooth surface. In the whole creating process, the most non-trivial step is the second step. There may be some questions like, how can we characterize the embedded shapes? Or how can we characterize the shapes with Julia? So let's start with some Julia script. Okay. Oops. By copy and paste the script, we can try the script. Oops. Okay. First, define the shape of the target surface. Second, define the domains of the strips. Like this, we need to only calculate these 10 strips because the target surface has 4 symmetry. And the next function calculates the embeddings of strips automatically. And the last function exports the paraboloid, the strips with SVG format. And the exported files are like this. We have 10 files which represents embeddings. Okay. The next section is about formulation framework. Framework consists of 2 parts, modeling part and numerical methods parts. The thickness of paper material is thin, so the 3D medium can be approximated with 2D surface. This surface is called, this strip is called reference state, M0, and the embedded shape is called current state, MT. The mapping is denoted to phi. The mapping phi can be regarded as elastic deformation. We assume 2 properties in elasticity. First is Hooke's law, and the stress is proportional to strain. There are 2 types of deformation, in-plane deformation and out-plane deformation. The thickness of paper material is thin, so the energy of the latter can be ignored. So let's answer the first question. How can we characterize the embedded shape? We characterize the shape MT by minimizing the elastic energy W of the embedding phi. So this is our concept of elastic surface embedding. This energy minimization problem leads the following big form PDE, and the unknown function is xi, which represents the coordinates of the current state. We use three tools to solve the PDE, B-spline manifold, Galerkin method, and Newton-Raphson method. With B-spline, the unknown mapping xt can be approximated by B-spline basis function and its coefficient. By using Galerkin method, the PDE can be discretized into a nonlinear equation like this. And the Newton-Raphson method can be used to solve the nonlinear equation. Let's dive into more topics on the waving theory. The output of the function was like this. So in the level, we have some tree structures like this. Okay. In initial, this 15th step is the initial state of this domain. And each line represents each step, and it corresponds to embedded shape and strain distribution like this. And the next step is Newton-Raphson method. This method relaxes the strain distribution and shape. Newton-Raphson method again, and the next step is refinement. This operation does not change the shape, but increases the number of control points. And this helps for more accuracy of the embedding. And Newton-Raphson method again and again, and finishes the computation of the embedding. The most mysterious part in the process is the determination of the initial shape. We obtained almost the same shape as in initial shape as in the final step. To create this shape, we use the next theorem. The statement of the theorem is a little long, but keys are just the points. First is the mapping phi is almost isometric, especially on the center curve of the strip, and the geodesic curvatures of these curves are almost equal. By using these properties, the embedded shape MT can be approximated and can be used as the initial shape of the Newton-Raphson method. We had 10 strips in paraboloid example, but was it enough, or can we decrease the number of strips? If the breadth of the strips is large, the strain in the medium will increase, and causes non-smooth surface model. If the breadth is small, the number of strips will increase, and the assembly process will be hard. So identifying optimal breadth is essential to obtain a smooth surface. Again, a theorem is useful here. This theorem approximates the strain in the medium. By using this formula, we can find the optimal breadth of the strips. In the practice, the show strain function can be used to calculate the strain based on the formula. So copy the this function, and oops. Sorry, I can't find some mouse cursor. Oops. It shows the predicted strain like this, and these strains less than are the less than 1%, so it should be okay. I'll show some examples. Oh, sorry. Paraboloid and hyperbolic paraboloid, and I'll show these results. The paraboloid is the most simple one that I have already shown. Hyperbolic paraboloid is like this. If I plot this surface like this, we can feel straight lines in the surface. The catenoid and the helicoid can be parameterized like this. And the most interesting thing is it can be deformed like this. sorry. Oh, sorry. I don't have enough time now. This is a sphere with stereographic projection. And if we light this model like this, we can find points on the floor. Oh, sorry. Oh, thank you for listening. That's all for my slides. Thank you to the Julia X system, because the following package helped this project a lot. I have some special gifts for you, weaving kits of this curved surface model. Thank you.
Thank you, Yuto, for the interesting talk. Unfortunately, we don't have time for Q&A. You can interact with him later. So we have next speaker.
Sorry?
You win JuliaCon. Can you light that up one more time so I can...
Oh, okay.
Yes, you brought the most beautiful object I've seen to JuliaCon by far. Can we turn off the lights? Is that what so
This is a mic.
Oh, wow, that's real. That's just awesome. Look at the shot. Look at that.
Thank you.
Have you made a
Oh.
I need your mic.
Sorry. Thank you.
So how do I pronounce your name? Eduardo?
Perfect.
Yeah.
Is your laptop?
Hello, everyone. So we have Eduardo M.G. Villa. He's here to present a talk on Interesso.jl, integrated residual solver for dynamic optimization.
Thank you. Yeah, thank you. My name is Eduardo. I'm a PhD student at Imperial College London. I work on dynamic optimization. And today I want to show you this package that I've been working on. I call it Interesso, so it's integrated residual solver. A lot of this might be unfamiliar to a lot of people. I just want to say, if you're familiar with optimal control or trajectory optimization, these are all the same things. They have the same mathematical formulation. So at the end of the day, we're trying to satisfy some dynamics, and perhaps we want to minimize or maximize some kind of merit subject to these dynamics and other constraints. Just to a bit of a spoiler alert, the results I'll be showing is that if you're trying to solve some problems like this Goddard rocket problem, where you're trying to see how high a rocket can go with a certain fuel, and you use a state-of-the-art method, like a pseudospectral direct method like collocation, it actually fails for a segment of the trajectory. And this is a property of this problem and many others. Whereas if you use an integrated residual method, it doesn't fail and it gives you something that more closely resembles the analytical solution. So this is the problem formulation here. So if you want to do dynamic optimization, you have a certain cost, but you can also just do the dynamic feasibility if you just want to see if something is feasible. So in the case of feasibility, you just want to find states and inputs, which are itself trajectories of time. And then there are the dynamic constraints over there. So this is where you put your ordinary or differential algebraic equations in the residuals function there. So that function has to be equal to 0 for all times in your time domain. Additionally, you have further constraints on your states and inputs, x and u. These constraints are actually an infinite number of constraints because you have to enforce these for all times in t. So that's when it gets tricky. You really need to discretize things. Additionally, you also have boundary conditions, so the initial conditions and final conditions on T0 and Tf. And this resembles the formulation of the problem that we want to solve. How do we do this discretization? So if you want something that converges quite fast, you should be using some kind of polynomials, unless you have a periodic function in which you should be using sinusoidals. So what we do is we create piecewise polynomial discretization. So for the states and for the inputs, as you can see there for the states x, we've created degree 2 polynomials in a piecewise fashion. And the values of these points become the decision variables of the optimization problem. Likewise, for the inputs there, u, they no longer have to be continuous, and they are here approximated by first degree piecewise polynomial. In order to satisfy the differential algebraic equations that you might have, you need to integrate these. So we integrate this residual function that we wanted to be 0. In this case, unlike collocation, we are oversampling. So we're evaluating at more quadrature points than the decision variables that we have. And this gives us the property of not having those singular arcs. And for this reason, you actually don't get the residual to equal to 0 exactly, because you have a finite discretization. Only if your discretization is of infinite number of pieces of infinite degree polynomials, you would actually have zeros in the general case. So what we're trying to do is minimize this dynamic constraint violation, the residual squared norm. So simply put, for the feasibility example, you actually have an infinite dimensional problem there that has the residuals as the objective function. This is what you want to minimize. And these are in the infinite domain. So you need to discretize it. And this transcription process turns these integrals into summations. As you can see there, we're integrating using quadrature. And we're doing the parameterizations using those piecewise polynomials. So now you have x and u, not the bold ones, become the decision variables, which are the parameters of the states and inputs. It's worth noting also that instead of just having one problem, you actually have a sequence of problems. Ideally, you would want to solve coarse discretization and then use the solution of that to interpolate and warm start a problem with a finer discretization. And so you end up with a sequence of optimization problems, which are parameterized by a certain mesh, which is how many intervals and how much degree of polynomial you have. What packages have I been using for this Intereso? I've been using MathOpt interface more recently to be able to plug and play different optimization algorithms. This is a very well-established package, and it allows for Intereso to be somewhat future-proof as other solvers might come up. And to take care of the automatic differentiation, I'm actually using reverse diff. It allows us to get fast gradients and Jacobians. So to show you how to solve that problem that I first showed the picture of, so here is how you create the states, the differential variables, more specifically. So you have your height and your velocity and your mass. These are the states of the rocket. We parameterize them with the second degree polynomial, so number 2 there, and then we apply initial conditions. And in the case of the mass, we apply bounds. Otherwise, the bounds are from -infinity to infinity. And then you have the thrust input, u, which is an algebraic variable here with its own initial condition. And that's how you formulate the problem. Some of the code is hidden, so the dynamic function is hidden, but this is what you provide. If you are doing a feasibility problem, you don't attach any cost function there, so with the nothing. And so these are the results. So if you look at a state-of-the-art solver, for example, the one presented in Betts, the book, you see that you actually have a singular arc for some of the problems like this one. Whereas if you take this least squares, which is an instance of the integrated residual approach, you end up with something more smooth and it's much more reliable. if you discretize this enough, it would closely resemble the analytical solution that we should have over there. The future work I want to have, so this package is still very much a work in progress. I've only implemented the dynamic feasibility functionality, so I want to extend this to have cost function associated to it. And the way that the problem is formulated is still very ad hoc to this package, and ideally there would be, just like JUMP has done, having this modeling language for mathematical programming. I think there should be one for dynamic optimization, so it would be interesting to have a more standardized modeling language. And yeah, that's all I wanted to present. I'm happy to take any questions if there are any.
Yeah, thank you. So we can have just one question.
So what solver was used? So for this, I used IPOpt for this demo, yeah. Thanks. Yeah. Okay.
Thank you. This one, right?
Yep. All right. Next talk's in Spanish. So if you don't speak Spanish, sucks to be you. Get on it. You should have taken better. You should have made an effort in high school. Okay.
Turn it on. Please turn it on.
Yeah. All right. Genau. Yeah. Oh, why is it not? The hell? Oh, beautiful. Presentation for ants. Yes. We're getting there. All right. Okay. All right. Mucho gusto. Yo llamo Miguel Raz. Esta es, creo que, mi primera presentación oficial en JuliaCon presencial, entonces muchas gracias. Bienvenidos. Yo les voy a platicar sobre Julia para gente con prisa, que es un curso de alto rendimiento que di en la Universidad Autónoma de México, en la UNAM, y a mí me gustó mucho porque metí la mano al fuego, ¿ok? Les voy a explicar por qué. Estos cursos consistieron de 2 unidades. Uno fue en el IMAS, en la UNAM, en la Universidad Nacional Autónoma de México. Es una universidad pública, tenemos más de 120,000 personas en licenciatura, y fue un curso para principiantes o gente intermedia en programación o gentes que son expertos en dominio pero con interés en aprender Julia. Quisiera dar un agradecimiento al doctor Ramsés Mena Chávez, a la doctora Claudia Juárez y a la doctora Ana Pérez Arteaga que están en el IMAS y en el ITAM específicamente. Este curso, una versión abreviada de este curso se presentó en MEXIAM 2023, entonces muchas gracias a la doctora Úrsula Iturrarán Viveros. ¿De qué consistió este curso? Creo que estoy hablando rapidísimo. Cuando uno no tiene mucho tiempo para comunicarle a los demás qué aprender en Julia, trata de escoger 20 horas para enseñarles qué vale la pena y luego soltarlos al mundo real. El enfoque del curso entonces fue qué tanto Julia le puede enseñar a la gente en 20 horas y que tal vez puedan, ¿no?, salir a mar abierto y puedan sobrevivir. Entonces, el enfoque fue en tratar de gastar solamente 3 o 4 días máximo en aprender lo básico de Julia, y después de eso tratar de enfocarnos solamente en aplicaciones y enseñarles paqueterías súper bien planchadas. Entonces fueron como 3 días básicos, obviamente un día de REPL completo, un día de enseñar la existencia de Pluto, y luego el resto del curso fue tratar de enseñarles cómo alguien profesional en Julia estaría usando un editor de texto. Entonces fue instalar el el Julia plugin de VS Code, que desafortunadamente no había documentación, fue tratar de ayudarles a tener unit tests, fue ayudar a enseñarles cómo descargar nuevas paqueterías, cómo manejar el REPL de los paquetes, todo este tipo de habilidades, los cuales día a día son la enorme diferencia. ¿Por qué? El gran problema que yo veía con la gente, que yo veo con muchos de los desarrollos de Julia que yo conozco en México, es que se quedan se estancan en el esquema de habilidades de yo sé operar un Jupyter Notebook y hasta ahí. Y desafortunadamente, eso no es todo el mundo, ¿no? Entonces, había que tratar de enseñar las aplicaciones para poder jalar paqueterías de data frames, usar online stats encima de eso, plotearlo, pegarle con differential equations, pegarle con file trees para hacer cosas en paralelo, todo el tipo de demos. Entonces, esa fue la meta de mi curso. Era Flipped Classroom, yo les proveía todos los materiales antes del curso, luego vía Zoom yo estaba resolviendo los problemas en vivo, constó de 2 semanas, 2 horas al día, estuvo bastante intenso a lo largo de 10 días, ¿no? En MexIAM fueron solamente 6 horas y entonces el gran tema que yo hice en el curso de Limas fue retar a los estudiantes a que trajeran curso en vivo. Entonces yo les dije, traigan código que ustedes usen para el mundo real y les vamos a tratar de dar la vuelta, ¿no? Vamos a tratar de o escribirlo en Julia o enchularlo en Julia para sacarle más performance. Y en el curso de MexIAM en el ITAM les dije lo mismo. Les voy a enseñar un demo de los códigos que trajeron. Algunas de las dificultades que enfrenté en este curso obviamente fue que las fuentes están completamente en inglés. Era difícil tener interactividad con los estudiantes dado que todo era online y es muy difícil tratar de reducir todo un temario de como enseñar Julia desde cero a gente que yo no tenía ningún filtro de si eran gente de licenciatura, de prepa y había gente con doctorado en estadística. Logros. Les voy a enseñar algo súper cool, que es este tweet de alguien que vio algo súper cool de Julia. Está aquí. No, esa es la siguiente presentación. ¿Dónde quedó? Oh, no. No. Es que no se enseña ya. Oh, no. Files. No puedo ver eso. Ok, pero sí lo puedo ver acá. Screenshots. Formats. Ok. Mientras estoy encontrando las imágenes, ¿me pueden hacer preguntas? Si gustan.
Si el objetivo fuera más performance del código, también enseña tools como benchmark tools, como eso.
Sí, entonces, la pregunta fue si yo quería enseñar performance, ¿qué tantas herramientas enseñaba? Entonces, definitivamente usamos benchmark tools, usamos profilers, nos metimos a medir allocations. En el curso del ITAM específicamente, traté de enseñar un pequeño modelo para tratar de estimar accesos a memoria y tratar de relacionarlo a lo que es veía a los códigos que vemos en el curso. Entonces, este es un tweet real de alguien que tomó mi curso. This person took my course and then they tweeted about it and I'm proud, okay? For good. So, esta persona lo tuiteó todo en inglés. Arturo Ordelli es un estadístico que estaba haciendo correlación de datos de COVID del gobierno mexicano. Su código se tardaba 30 minutos y lo bajó a 45 segundos. So it went from 30 minutes to 45 seconds. That's pretty freaking good for a course for someone who was coding for 6 years in Julia, ¿no? Y estoy muy orgulloso de eso. El otro curso, entonces, este fue el del IMAS, que fue exitoso, al menos en este respecto, de alguien de la vida real. Y en el caso de el ITAM, yo le pido a los estudiantes que me trajeran un código y les puedo enseñar este resultado. Dame mi mouse. Okay. Este es un código que del lado izquierdo está mi versión en Julia, en R, y en el lado derecho es un código en R que un estudiante me dio a mí. Me lo dieron el miércoles y para el jueves yo ya lo tenía hecho. Es un minimum cost flow sobre una gráfica o algo así. Eso no es lo importante. Lo importante es que el código a la derecha corre en… Vamos a ver. R. Yep. R. Apuestas. Ok. Art script, agente viajero. Más o menos, 0.05 segundos. Ok. Y en Julia, agente viajero, el mismo código. Eso. Entonces, la imagen importante es que línea por línea, lo que más tuve que hacer, perdón, AV, fue quitarle estos signos y quitarle los corchetes squiggly. Y ya, son línea a línea el mismo código. Y sacó un factor de como 30,000. Y para mí eso fue lo más importante, llegar con gente y decirles, ustedes pueden hacer muchísimo mejor código, en lo que van y aprenden Julia y regresan, ya acabó. Gracias.
Thank you, Miguel, for the interesting talk. Next speaker.
Sí. Si me invitan. Sí, con gusto, doctor Ramses Mena, por favor. Y también sacar videos para las partes como instalar JuliaOp, instalar el Julia plugin, instalar VS Code, saber usar, no sé, benchmark tools, todo ese tipo de contenido que se puede tiktokificar y hacer de mayor facilidad a la comunidad, estaría muy bien enseñarlo. Pero sí, si están interesados en un curso en español, háblenme, armemos temario, jalo.
So how do I pronounce your name? Rachel Kurchin? Thank you.
Okay. Hopefully this goes the right way. All right.
Yeah. Hello everyone. So we have Rachel Kurchin. So she's going to present a talk on teaching introductory material science with Pluto demos. Over to you, Rachel.
Hi, everyone. We're back in English. I was excited to be able to basically follow that talk, but my Spanish is nowhere near good enough to present in Spanish. I also taught this course in English. So anyway, my name is Rachel Kurchin. I'm junior faculty in the materials science department at Carnegie Mellon University. And I taught the freshman first-year undergraduate introductory materials science course this past spring. And I'm a computational materials scientist, so there's no sort of computational prerequisites for the course, but I wanted to expose them a little bit to the power of computation to sort of help us understand things in materials science. And I worked up a couple of demos, so this talk is just going to show you a little bit of that, and maybe teach you a tiny bit of materials science, and also offer some of my own kind of reflections on how it went, what worked well, what was maybe a little more challenging, and what I hope would work even better in the future. Okay, so a little bit about the course. I already said a little bit about this. It's if you happen to know CMU course numbers, it's course number 27100. The title is Engineering the Materials of the Future, because we have to give them like fancy, flashy sounding names, but it's Introductory Materials Science and Engineering. These courses are aimed at first-year undergraduates. So it's the introductory course. It's the course that's aimed at sort of tempting students into the major to like join our department for their undergraduate degree. And critically, there's no science or programming prerequisites. I happen to teach it in the spring, but it's the same course is offered in the fall, so they can be absolutely first semester, so we can't really presume any background knowledge of programming or anything like that. It's a survey course. It touches on a pretty wide variety of topics, materials classes, all of these sorts of things because the goal is to show them what materials science and engineering is about, get them excited about it, show them a little bit of everything. This, of course, presents some challenges because you can't really go deep into anything, right? I mean, the way I did it, I sort of chose to choose a few little snapshots to go a little bit deeper on, because I think it's important to get a taste of what a more deeper, detailed analysis of things looks like, but it's fundamentally a survey course. So the idea is to expose them to a lot of different things. The way that I organized it was themed around this thing called the materials tetrahedron. It used to be a triangle, and then they decided they had to make it in 3D. Professor Kurchin's hot take is that it should just be a triangle, because there's not that much difference between performance and properties, really. Performance is just kind of a particular weighted average of properties for your given application. But anyway, here's the materials tetrahedron. So this is really the core of materials science, is understanding these aspects and the relationships between them. So we have structure of materials at many, many length scales, so understanding structure down from the atomistic length scale all the way up to a chunk of material that I can pick up and hold and throw against the wall. Properties, so things we can measure about a material, its density, the way that it interacts with light or mechanical forces or anything like that. As I said, performance is really just how it performs in a given application. In my opinion, it shouldn't really be a separate thing. It's just kind of what properties are important for your given application. Processing, so how the way that we process a material can impact these other pieces, and then we often put characterization in the middle because that sort of ties it all together, how we actually, understanding how we measure these things, what we can measure, what's harder to measure, all of these pieces are really important. A really kind of foundational thing that often comes up in materials, it's most commonly introduced in the context of material selection, so how do I choose a material for a given application, is this thing that's frequently called an Ashby plot. It's named after some guy named Ashby who came up with plotting things this way. And basically the idea is you can plot a bunch of different materials or materials classes. Oftentimes these are sort of logarithmically scaled axes, so it'll be two different properties, and the goal is to understand what's the sort of relationship between these properties? There's some sort of like Pareto type constraints that we can't really do better than a certain maybe ratio or some sort of relationship between these properties, and just sort of thinking about where we want to sit on that in selecting a material for an application. But there's also a lot we can learn about it in terms of understanding, why do these relationships exist? What about the structure, properties, processing relationships lead to these kinds of fundamental constraints? And then, of course, there are people who want to engineer new types of materials, fancy composites, this and that, to sort of move beyond these constraints. So the first little notebook demo I cooked up was, okay, this is going to be an interesting challenge because it's not mirroring my screen right now, but once I find the mouse, there it is. So basically, I took, and this is a pretty small data set. I think there was like order of 100 or 200 materials. It was just one that I found that I could download that had a bunch of different properties defined, and cooked up this little thing. So basically, the only thing I asked them to interact with, this was as an in-class activity, was to just sort of play around with these two dropdowns and sort of make their own plot. And then I had some stuff below that they could go and look and see, like, how did I actually pre-process the data and do all of these sorts of things. But really, I didn't want them to have to interact with the code directly at all, and Pluto was a pretty great venue for that. So, okay, so we have density on the x-axis, let's put something else on the y-axis, we can try thermal conductivity, okay, that's kind of interesting. Maybe specific heat, what happens there? Oh, that's kind of interesting, you see a sort of Pareto thing, and of course we get these nice little tooltips, and I set some colors by material as class, so we have, let's see, the gray was metals, the yellow ones are ceramics, the blue are polymers, and then I think the green were composites. Yeah, so we can see that not only do we see some relationships between these properties, but there's sort of clustering based on the sort of chemistry, the materials class. And basically, I just sort of set them loose on this for a little while and said, like, look at this, what do you notice? Do you want to like, oh, that's the same one, that's not that interesting. Can you sort of conjecture why these relationships might exist? And I'll note, I did this on the second day of class. So they didn't really have any of the sort of formal vocabulary for any of this stuff yet. It was really just like, let's think about, based on what we know from, high school chemistry or whatever. Also, they can think about things like data. There are outliers in data, right? Like, does this material really have the high coefficient of thermal expansion? Like, I don't think so. So we can talk about like sort of messiness in data as well. It's a cool opportunity for a bunch of different kinds of things. So this was the first one. I'll go back to the slides now. And then the second one that I want to show you is related to crystal lattices. So this is a really, really foundational topic in material science and engineering, understanding how we characterize crystal structures in terms of how their symmetries, the shapes of the repeating units, the unit cells, all of these kinds of things. In distinction to a lot of the other early topics in this course, this is new to almost all of the students. Thank you. So a lot of other things that they learn in this class, they've seen a little bit of in a high school chemistry or physics class, and it's like sort of maybe seeing it in a little bit different light or framing it in a different way. This is a fundamentally different kind of topic. I'm running pretty short on time, so I'll go by this pretty quickly, but another piece is that 3D visualization is a really important skill here, and it can be a big challenge. So the other notebook I'll just show very, very briefly is meant to help them be able to sort of visualize crystal lattices as a function of the properties that or the sort of parameters of the unit cells. So we can change the lengths of the lattice vectors, we can change the angles with the nice little sort of Pluto draggy bits, and they can sort of drag around and see what this thing looks like, and it shows the primitive cell, and I made some buttons so that they could sort of snap to common standard crystal structures. All the stuff is on GitHub. I think I might have forgotten to put a link on the slides, but I'm R. Kirchen on GitHub. It's in there. It's called 27100 Demos, so feel free to go take a look and play around with it. There's binder links. They take like a really long time to spin up, which gets me to my reflection slide with the little bit of time I have left. So I think Pluto is definitely a great way to expose students to the power of computation and sort of working and playing with data without them needing to actually write any code themselves. One thing I was worried about was like, would students have laptops, or would they forget to bring them to class, even though I reminded them the day before, or things like that. That wasn't an issue. Enough students, like more than half the students brought laptops and tablets so they could sort of do it themselves or sort of group around with a buddy, so that worked really well. The startup time of the binder thing was a big issue. I didn't want to have to make them install Julia on their machine, so I used this great thing that, I don't remember who it was now, if it was Fonz from Pluto or somebody else, hacked together a thing where you could actually run a Pluto notebook on binder, but this took like 6 to 7 minutes to spin up. And so I'm hoping that in the future that's something that some of the Julia Hub tools around Pluto can address and make things smoother. That was really kind of the only downside that I ran into with this. I felt otherwise it worked well. I wish I'd had more time to make even more of these demos. And yeah, that's all I have. Thanks for listening, and I'd be happy to discuss more with anybody.
Thank you, Rachel, for the wonderful talk. Next speakers.
Can I just say 2 things?
Yeah.
So I'm Panagiotis from the Pluto team and Julia Hub. And for Julia Hub, the answer is yes, you can use it. And if it doesn't work, just call me.
Amazing, thank you.
And we would really like to see this notebook. So we have this notebook idea in Pluto where you can submit your notebook to become a featured one. So these notebooks look great. Please submit them to github.com/juliapluto/feature.
Will do. Sure.
Possibly here for more simplicity, but then we will make them in. And there's also a Pluto contest in the Julia Hub where you can also submit them, and the prize are $500, $300, and $100. You should check the blog post. Some tagged it if you have it. It runs until the 1st of August. Please submit your notebooks, and everyone else that has, we at Julia Hub will be very happy to get them.
Wonderful, thank you.
Offline, I'll get feedback for education.
Thanks.
Great.
What's up? All right.
So we have next talk. That is the Slack thread that would not die by Miguel again.
Come on, it's the other one. No. So that's the pop quiz. No, God, it's showing it here, not there. Okay, but it's good to know I have that on the quick draw. There we go. 3, 2, 1. Slideshow. All right. What's up, everybody? My name is Miguel Raz, and we're going to talk about some Julia memes today. Raise your hand if you're on the Julia Slack. Condolences. All right, next. This is a love letter to all my online friends who are as extra as I am and so willing to go perf chunky on anybody else's playground. Let's go. All right, so there's a Slack thread that is 1,224 messages long. At least it used to be. I am now posting to the Gripes channel. Only post to it during this JuliaCon presentation, and let's never speak of this again. All right? So, Jerry Ling posted, this is 9 months ago, all right? It was still going after 6 months. Please. And then, I really don't know what jobs you guys have, but can you please refer me? I want to join. And Gabriel says, I watched Julia build. So, not untrue. So first of all, this is a Slack thread that was set off because somebody put a public benchmark online. I will be the one throwing stones living in a glass house. So before you come for my friend Nicholas here who published this, who deserves all the praise and round of applause, let me put my hand into the fire and say, I've been there, right? I've been there and said, hey, what's up? Julie's super good at adding up 100,000 integers or something. And then Ken Fisher very kindly says, no, it does not do that. It just does the Gaussian addition formula. It's like 3 instructions. That's why you only get 2 nanoseconds. And I got to be corrected in private before I post it in public. So, what was the actual benchmark? This is what that repo was. It was a guy just trying to learn different programming languages, set up their dev containers, was really nice about it. And then all of a sudden, the Julia people came and completely ran over the playground with all of the enthusiasm that probably shouldn't have happened. All right? I couldn't get an image from before because it was a bit hard to like mine it. This is kind of what it looked like at some point. Like Julia wasn't doing too good. Go and Nim were at the very top. Like there's all sorts of like weird choices that happen. We'll go over it. But what I want to highlight is that this is how we started, all right? There was some other stuff. It was just straight up timing Julia, opening the file, running a global loop, not even JIT compiling, all of the fuck-ups that people who are beginners to numerics would make, that you or I would have made on our first day of learning these things. But this person put themselves out there. So, spicy take time, right? This person put themselves out there. They made a repo. They actually went so far as publishing a YouTube video so that people would know how to contribute to the benchmark. So, my spicy take is that whoever is willing to share their code openly contributes more to the actual scientific spirit of our times than anybody else who just is, who has not shared their work about brand new kinds of physics since like 20 years ago. So if you know any grandmas that share cooking recipes, they're basically embody the scientific spirit more than a guy who may or may not have spoken at JuliaCon yesterday. All right, so this guy actually went online, posted a public video, and said, hey, if you want to help out, this is how you do it. Made a whole tutorial about it. So round of applause for Nicholas, please, because, you know, if you come for him, you got to come for me first. All right, so what actually happened? Let's get into the perf core. This is the kind of stuff that people would enjoy looking at after 1,000 Slack messages at some point, right? Just beauty, you know. We got signed integers, the floating point, we got all the SIMD registers, those things in angle brackets, all of this. It's not going to make any sense. I make no attempts at trying to summarize 1,000 messages in Slack. I'm just picking out the highlights and having fun here. Michael Abbott says, oh yeah, we can just do a one-liner and beat like all of the other languages in the benchmark at some point. That was pretty cool, right? And then we get to go, oh, right, unfortunately, it doesn't SIMD. And then people would go back again after SIMD. That wasn't the important dynamic. The important dynamic was that when people would get a new Eureka, like every 3 weeks, and revive the Slack thread, right, and kept re-zombifying and killing it over time, and it would just not die. There would be pleas of mercy, recurringly, for people to be let go from the notification hole that is Slack, all right? If anyone has time to set this up, could you please help me with this sign vector? This was a gnarly optimization that Michael also came up with. Jerling obviously commented, oh my crap, oh yeah, holy crap, it's 2 times faster, works with static compile, go, 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 let's try and get that in, right? There were multiple pull requests that this person accepted. When we ran out of Julia code to optimize, we went and pull requested for the Fortran and C++ codes because they weren't using our optimization, so why not, right? We ran the playground, no? All right, this is the moment to do something that we haven't done enough at JuliaCon. There is not enough, you know, naming and shaming of evil code. So I want everyone to participate in the first public JuliaCon code exorcism. There is among us a sinner who will be named. Dear viewer, this is Mose Giordano. Mose Giordano submitted the following pull request. It's a diff, and so I'm not going to show it, but if you can see that code, it says, oh, f of 1 just returns a double. That happens to be pi. Julia likes to use this loop. This was completely cracked the benchmark. Mose was so clever, they came up with a constant time algorithm, which is this. Please. This. So, let's bask in the evilness here. Something is happening with my VS Code that is actually letting you know that something tricky is happening. From the giggles, some people might know what's happening. Mose defined this pi, you know, did some math on it, but returned float pi. If you happen to know anything about homoglyph attacks, there's a pi already baked into Julia, but that's not the P from pi. That's a Unicode character letter that looks like it. So you can just return the pi, and Julia will say, oh, you didn't use this loop. So I want everyone in this room, raise your right hand. Raise your hand. Everybody point to Mosè Giordano. And now we say together, evil be gone. The power of Christ compels you. The power of Christ compels. Yeah, all right, thank you. Thanks. And so the end of the benchmark was something like this. It got all garbled up with the input, but at the middle of the top, stack, there's a Julia AOT compiled, and they're all within like performance benchmarking noise of each other. So woohoo, we did it. We did the numbers. What's up? And then there's just a long tail of other languages that didn't hit the SIMD optimizations, and so they're like 2x faster or whatever. And then there's a long tail of wannabes who can't run like Julia does. So congrats. I love you people. Thank you, Julia community. You rock. You are crazy, and I love that. Thank you.
Thank you, Miguel, for the wonderful
I will
talk.
not be taking questions. I will be taking confessions, Mosè. All right, awesome. Thank you.
Hello, everybody. How's everybody doing? Or does this even work?
Yeah.
Oh. I'll plug this in first. Everybody take a little stretch break, but it's like 2 seconds. Let's see if it's going through. Oh, okay.
Yeah.
That's why I couldn't hear anything. Is this good? All right. Hello, everybody. My name is James. I'm here to talk to you about how I am trying to teach Julia through GitHub. This is me in high school. I think it's a very good picture of me. I want to appear younger. I'm a scientific machine learning enthusiast. I work in mostly biomedical data, and I love open source, and I enjoy a good joke. I've been seeing Julia around for a while, but this is my first JuliaCon. I've really enjoyed the language over the past year. We're in the age of ChatGPT. I know this is kind of going to scare people away because nobody wants to talk about AI because everybody is. But I was thinking in terms of how easy it is to create code now. I have a question, just do this in Julia for me. Now there's a lot of problem with hallucinations and all that jazz, but I try to put myself in the shoes of somebody who's younger, not as experienced programmer of oh, I just want to do this and put it through. I just want answers on this, as opposed to actually learning the syntax of the language and the little ins and outs. Because a lot of Julia is that in terms of optimization, getting the JIT right, all that jazz. And the way that I put that in is that basically that if you want an easy answer for stuff, that's going under. So the way that we've been teaching stuff like programming languages in general kind of needs to change, as opposed to I have a question, how do I write it, go through that. And then even if it's easier than others, Julia's, I think, is a bit of a straightforward language in that way. It's not like Haskell and all that jazz. It can be hard to learn, especially to beginners. We have a ton of interesting use cases in the community. And all of these, though, are also kind of opaque in terms of, do you know trajectory dynamics, all that jazz? Do you know stuff of imaging and MRI? If you're a programmer who doesn't quite know this, how do you get into the language itself if you want to contribute and be a very productive member of the community? And because of that melding between programming and science all at once, we do have stuff like the Julia Academy, but a lot of that is notebooks that people go through to try and you run it, as opposed to something a bit more dynamic. I put a pros and cons here of just you can put it out in terms of this notebook, try to solve this for data frames, all that jazz, a lot of stuff Logan K had done in the past, which was really good. There's a lot of good things for that. But the problem with that is that it's really siloed from what you would actually be working on day to day when you're trying to learn. And basically, there's not a lot of community help of stuff that you have to go in and prod it yourself for this, sort of get on that big Slack thread to find all the answers in the universe. Thank you for the talk beforehand, by the way. Basically, I'm just talking about some obstacles here in terms of, yes, Julia is very science-based, but it's also very, I don't want to say insular, but you have to know the topics that you're working on in order to contribute it when it's very hard to be a beginner and ramp up for it. And I think that's to its detriment in a way in terms of open source and being able to help out packages. So then, while I was going through this, does everybody know what Hacktoberfest is? So yeah, I really love Hacktoberfest. It's really what got me into open source and contributing stuff because I really wanted that T-shirt many years ago. Very weird incentive to go through it, but it worked. Basically what it is, for you don't know, is that you make full pull requests for participating repos. If you do that and they're tagged correctly, you get a T-shirt or you'd be able to plant a tree. And the idea is to get people to contribute to open source code a lot more. The issue of this is sort of what I was describing beforehand in terms of people are not maybe like experts on the field of whatever repository they're contributing to and they don't know what to do. So you get a lot of bad code, a lot of stuff that people have to grind through. They've made changes to the rules where like you have to opt in to be at a Hacktoberfest repo and all that jazz, but I still think there was like a thing of like, how do I even approach this? And a repo I loved was called the Haskell Learn for Haskell Hacktoberfest project. Basically, what it is you make there's 4 chapters in there of you learn how to actually write Haskell with like interactive things, like you'd fill in the blanks over here, or allow it to do this. And it runs GitHub Actions, and the community looks it over to verify it and make sure it's good for it. So it's like, oh, this passed, this works, this didn't. For beginners of a language like Haskell, which is a functional language, in case anybody didn't know. And I found it really easy to start to learn how the language actually worked and monads, all that jazz. Like these are the different types of things you could learn for Haskell. And I thought that was a great paradigm shift because usually like pull requests are one person contributing to like one big repo in the community. This is a way of like the community like giving back in terms of like, oh, it's not just contributions. You're going to learn how to actually do that for it. And I thought that was a... Oh, 4 minutes. I thought you were just showing me the number 4 for no reason. Yeah, because it's learn for Haskell. I'm like, what a cheerleader. Yeah, sorry for that. But basically, within that, I thought it's like, this is a really good idea in terms of having to do that with Julia. Basically, you make a lot of repositories on this in terms of like, you build similar chapters. Sorry, I'm just going to bounce around a bit more of this, that like these are example tests, stuff you do for differential equations, and Flux, still some kinks being maxed out, but the idea is you can asynchronously put stuff in and see if it passes a test or not in terms of, did I code this correctly? Is this giving me like a result that's within it? Is very good for async learning, and then giving guidance by people. It's like, oh, they just have a PR up. We can go through it. I also put sort of the steps for like how GitHub Actions actually work through here in terms of it's like you have the workflow, you have the job, you take a step in action, in which case like pass, fail, through it. And just to sort of like before and after within it, I really should have, it's like inputting the function here in terms of train, getting the optimizer for it, like learning the actual package of Flux within it. And I really like that idea. I've not opened it up to a lot of people yet. Like the repo is live, but it's more of like experimenting with this because I thought it's really important to get people to use Julia a bit more. This is the idea of like once you finish the conceptual chapter, it closes the PR automatically. So it's like, okay, you've passed. And in this case, it's accepted into like the GitHub, Hacktoberfest for that. And what I like about that is Julia, again, just can go all the way back here, has a lot of different ways that this can be used, from robotics to earth science to MRIs. And I think this is like a nice, easy project in the fall for people to go do to help out in. I was also thinking in the future in terms of like what would be very useful for a project like this, in which case like not everybody has time to check on the community and build more stuff. And I don't want to like continuously push like ChatGPT, LLM stuff, but thinking back to my time with Learn for Haskell and Hacktoberfest, that basically having a little plug-in to say, like, hey, you did this right, this is the correct syntax for that, or to create new things to keep up what's the most popular. Like these are the ideas that I've had that I've worked on and put in there. These are some future stretch goals I've started to work on to put in with it. And yeah, I think there's a lot of stuff for this community to sort of grow and get new people excited in the maths and sciences, and of course, Julia itself. I'd like to give a thanks. Obviously, I took the idea from Learn from Haskell, the Vroom 991, who is the owner of the repository. And basically, again, like Logan Kay, who did a lot for me going into this and seeing what he's done to help educate the community in Julia. And if you want to contribute, here's the QR code for it. That is for the GitHub repository, not my Venmo. But if you do want to give me money, I will be available after the talk. Anyway, yes, that's it. Any questions?
So we have 2 minutes for questions. Thank you.
Clear to the point.
Thank you. Next speaker, please.
It's reconnecting, so maybe you can present through here. Might not be the best idea because of the internet. Let's pass this up. No, it's not. Okay. Hello, everybody. Thank you so much for being here. So today, myself and Jacob Zackel, we will be talking about the Julia Diversity Initiative and also the outreach teams we have in Julia for different languages, for non-English speakers, and we hope we can connect to the internet. Just give us a second. Yes. Okay. Yeah,
Okay.
worked. Yeah, sorry for that. So first, a brief overview about our talk. We will be talking about the Julia Gender Inclusive activities and initiatives and opportunities. And Jacob will be talking about the Julia Community Outreach and Development Fund and how you can get funding from it. And also about the other Julia Community Outreach events and future directions in our work. So stay tuned. The Julia Gender Inclusive is an organization that focuses on underrepresented groups and tries to grow the community and bring more people from different genders. And if you see yourself as a gender, your gender as underrepresented, we invite you to join us in our organization, our Slack, and we are happy to welcome everybody and make this community warm and welcoming. Some of our initiatives as an organization, we had the Learn Julia with Us. It's available on YouTube, and it's an initiative for beginners to learn Julia, and it's made from people from underrepresented genders, and we hope this initiative can bring more people to the Julia community. Also, we had a very nice event last year. It was a day-long event, a hackathon, in which we brought mentors from the wider Julia community. And we had very good outcomes from this hackathon. 2 pull requests to the documenter.jl repository, and we also released our new website. So if you want to take a look at our initiatives, take a look at our links, you are welcome to visit as well. And we thank all people that helped mentoring and organizing this hackathon last year. And we hope to have next versions soon, and we will be disposing dates. And now we are planning to have the community hours back. This community hours will be hosted on GatherTown, and the next one will be disposed. We are talking to some people that are interested in joining and giving us a talk. And these community hours are to discuss the state of Julia community, comment about your experience, and it is supposed to be a safe space for everybody to chat and build connections. So We hope to see everybody there. So this is a summary of the activities I just talked about, and you are welcome to join our Slack. And now I'll be giving the microphone to Jacob.
Awesome. Thank you so much. Oh. Awesome. Thank you so much, everyone. My name is Jacob Zelko, and I'm also here introducing the Julia Community Outreach and Development Fund. This is kind of a pilot, first of its type initiative within the Julia community, dedicated to supporting individuals or groups from non-traditional or minority backgrounds. This is intentionally expansive and broad for the community fund. As you could imagine, there's various different ways intersectional behaviors or backgrounds can lead to being underrepresented in the Julia as well as STEAM communities. So just to give some examples of what I mean by these underrepresented populations, for example, first-generation college students, non-traditional individuals who pursued non-traditional career paths but found themselves within the Julia community, as well as individuals running or coming from single-income households. Now, with the community fund, it is hosted on Open Collective. All the funds, as well as donation history, will be present on that in a very transparent way. Additionally, with a huge thank you to Avik Sen Gupta as well as Logan Kilpatrick. This is under the NUM Focus umbrella, so I need to double check, but I think we should be under that 501(c) status. So for tax benefits, that might be of interest to individuals who might want to make a contribution in the future. Additionally, this initiative should be set up in such a way that individuals can receive funds, be able to work within the Julia community, and as a result, these sort of funded projects that individuals might pursue can benefit the broader Julia community. And what I mean by that is, for example, we can help with supporting community creators within the Julia community, such as developing Julia learning resources for the classroom, or also routine maintenance or updating of pre-existing resources within the Julia community. These are designed in such a way that they're for small grants. I call them micro grants, if you will, taking some vernacular from Amarita Sen as well as Mohammed Yudis, seeing how we can elevate individuals with, in United States term or US dollar terms, rather small amounts, but to be able to support individuals who might just need that money to maybe, for example, hire a sitter for 20 hours to go through a Julia Academy course to learn how to go from 0 to 100 with Julia Academy and data frames, or so on and so forth. Once you apply, you can expect to hear a few weeks back after the application process. And I talked to the community fund chair, and being as I'm the community fund chair, I can also say this is a relatively early stage community fund. So please reach out to me with applications as well as going through the process. We do have a website that we are in the process of standing up. If you're interested in getting involved more with the community fund, we can scan that QR code and learn a little bit more about it. It would be great to have you involved. And then also, just to kind of round out this conversation, I did want to highlight some of the other pre-existing community outreach groups within the Julia community, which is, first of all, the Julia CN, Julia Chinese Community Group. I was speaking with both Johnny Chen and Roger Liu today. Johnny couldn't be here, unfortunately, so to highlight what Julia CN is, it's a Julia community user network for our Chinese Julian friends. And as you can see here, they actually have their own discourse stood up, as well as an existing translation program that you can apply to and actually receive funding for to develop Julia resources in the Chinese language. Also, I just learned today that the population for this group is over 2,500 strong, which is pretty incredible, as well as it's also a benefit I've found out to some of the other neighboring countries, such as South Korea. So if you're interested, please reach out to Roger Liu, myself, Johnny Chen. I'm happy to make connections. Also, there is Julia Essay, which is for translating Julia resources to Spanish, and that community group continues to be very active. If you want to learn more about Julia CN, scan that QR code, and I'm happy to also get you in touch with individuals within the Julia Essay community. So future directions for overall our community outreach could be developing resources for accessibility, such as supporting those with visual impairments, speech to code. And additionally, if I've missed anyone in this process talking about other efforts, please let me know. I want to, continue to highlight and, elevate you in the community. So with that being said, just as a reminder, we have our gender-inclusive Birds of a Feather today at 11:30 to 12:30 p.m. And thank you so much for your time, and we look forward to your questions.
Thank you. Any questions?
Just a quick reminder, the birds of feather will be placed in this room. So if you want to follow the discussions, just stay here and we'll talk soon. So questions? Comments? Concerns? Okay, thank you so much.
Thank you.
Check, check. Yeah. It is working, no?
So our next talk is by Christopher. So he's going to speak on a brief history of the Julia repository.
Thank you. So now with JuliaCon being 10 years, I thought it would be a little bit fun to look at the Julia repository and look a little bit on the different things that have been achieved there very, very shortly. So first, a little bit of some stats. The very first commit to the Julia repository was made in August 22, 2009 by Stefan with the classical initial empty commit message. So that was 13 years and 11 months ago. I had to use a little website to calculate that, so I hope it's correct. But maybe interesting, the second commit is by Jeff, and it's the beginning work on the parser. The total number of commits right now is 55,000, and if you sort of divide that with the number of days the repository has been in existence, it turns out to be around 11 commits per day. The total number of issues that have been opened in total are 23,300 approximately, and right now we have almost 4,000 open, but almost 20,000 closed, so that turns out to be around 16% of the total issues open. Looking at the pull request then, we currently have 939 open, a total around 27,000 with 939 open, and many closed, 26,000 closed, so there are around 3.5% of all pull requests ever opened are currently open. The total users who have opened issues seem to be around 4,000, with the total number of users who have opened pull requests is a bit smaller, which is natural to see because opening a pull request is a little bit more work. So it's a little bit under 2,000 there. If we look at the commit activity, we already discussed this a little bit in the keynote today, but you can see that after Julia 1.0, the commit frequency went down a little bit. And I think explanations for that is that people actually started using Julia for things. The language is good enough that you can use it for things. And we also moved out some of the standard libraries to external repositories. So for example, the PKG standard libraries in a separate repository. So all the work there is not reflected in the commit activity graph here. We can look at the star history of the repository. So we can see sort of an inflection point here, which is naturally when 1.0 was released. And of course, that's going to give a bit of a bump. But what I think is interesting, if you look at sort of the rate of stars before 1.0 and after, you can see it's a dramatical increase in the rate of stars, and the trend keeps continuing. So I know there was a little bit of critique. We released 1.0, but looking at this, I think it was really the right thing to have done back then. We can also look at how the number of PRs have evolved over time. So the green line here is the total number of PRs that have been opened. And the pink line here is the ones that have been closed. And then down here we have the ones that are currently open. So this is then a time graph here from the start of the repository to today. And then here we have when Julia 1.0 was tagged. And we can see that the number of pull requests kind of started increasing exponentially here but then after 1.0, it seems to be more of a linear trend. And the graph here for the total open pull requests, it's a bit hard to see. So on the right-hand side, we have sort of the total number of open pull requests here in the blue line. And that uses the left y-axis then. So around now, we can see it's around 900. But then the purple line, we can see the ratio of open to closed pull requests. So we can see that we're around here now, which is around 3.5% of all pull requests are currently open. And a bit interesting, I thought, is to zoom in on these points where we have very big reductions here. And I think that can be explained by someone just deciding that, okay, now I'm going to go through a lot of pull requests and do a lot of work. So a lot of work can happen at short times. Doing the same for the total number of issues then. It's not that much to say, but we can see that the ratio here for total number of issues seems to converge right now to about 16% of open issues to the total number of issues that have been opened. And then I want to give some Julia repository awards here for different interesting situations. So we have the pull request with the longest title, which is by Edelman, and I want to read this out in its full. So it's interactive utils version info. When verbose is equal to true, print environment variables that might affect the network options stdlib. Also, try to redact some, but not all, sensitive environment variables. Then we have the fastest pull request merge, which was made by Jacob Polewski. It was called Fix Some Syntax Deprecation Warnings in the perf folder. It was opened there 2014, 10.07, 21, 16, 24, and it was merged the same day, 21, 16, 28. And I was not around at that time, but I was really impressed how fast CI was back then. And then we have the slowest PR merge by Simon Byrne, and that was the remove type parameter from abstract triangular. It was opened in 2018, and it's actually merged just a few weeks ago in 2023. So that was open for almost 2,000 days. So when you're complaining that your PRs don't get merged quickly, you can talk to Simon, because maybe he has some things he can share his experience. And then we have the most discussed issue, which was by Yihao, and that's the classic taking vector transposes seriously. And that one has 417 comments. And then finally, we have the issue with the most labels I took out. So that's an issue here. It's the wrong sprint output with the flag. That issue is still open. It has the backport flags, like, okay, this should be backported. It's a bug in a regression. It has to do with display and printing. And I like this label here, forget me not. I think we can replace this one by saying, I am forgotten, because it seems to fulfill kind of the same purpose. So yeah, that was a very short look at the Julia repository. Thanks.
Thank you for the interesting talk.
Yeah, question there.
So you gave the extremes.
Yeah.
And I was wondering if you had a plot of the lifespans of pull requests.
Oh, that would be interesting to see, like the halftime of a pull request. I don't have that available here, but yeah, would be an interesting thing to plot. Yeah.
And presumably there's a long tail of pull requests that will just never be addressed or something.
Yeah, I mean, there's always these pull requests which are like, maybe it's going to happen at some point, so you don't really want to close them, but it's kind of unlikely maybe, so there'll probably be a long tail of these things that keep going. Well, the slowest PR merge might be a bit hard because you have to wait for a long time for that one. If you're really fast on the button, you can probably beat this 4-second one, but yeah, I mean, that's the easy one to do, yeah. But, next year there might be a different award, so you don't know what's going to... Simon?
What I want to know is,
Oh, that's a good. I think the hard thing with this is that sometimes issues are open very long time and then they're just closed because someone says this is not relevant anymore. So you want to have like it's closed because it got fixed somehow. But yeah.
I'd like to comment that second commit in history, that's the code I'm trying to
Yeah. So, yeah, I was actually thinking about mentioning that this big. Yeah, so we're having this beginning work on the parser is slowly being undone and replaced. Yeah.
Yeah, I'd also like to thank you for being the only presentation I've been to at JuliaCon where I had a chance of reading the slides.
Okay. Yeah, I tried to make things readable at least somewhat. Oh, yeah.
So this is more of like a less happy question. So like if the trend of commits and stuff and lines of code is just like whoosh, keeps getting bigger. Is that sustainable? Is there any plan to not just like get a bigger and bigger repository until you can understand it?
Yeah, I think one thing we did with the 1.0 release was the standard library thing. So we had felt like we had so much stuff in the repository and then things were moved out into standard libraries. So that was sort of step one. And then as was mentioned in this keynote today, the idea is to have these standard libraries be kind of upgradable. And at some point maybe they'll move out. So the point there is to sort of have the core Julia compiler be one thing and then have the standard libraries be a little more free so they're not like in the repository itself.
Thank you. Okay, so we have next talk by Harshita. So she's going to speak on a qualitative study on challenges faced in multi-threading in Julia. Over to you, Harshita.
Good morning, everyone. So good morning to all the smart minds sitting over here. I am sorry beforehand if I say anything wrong because I'm doing my debut in conferences. So this is my first ever conference that I'm attending. That is too by JuliaCon. So if I do anything wrong, I'm really sorry. And a disclaimer beforehand, no packages, no code, just a qualitative study that I'm representing. So this is a study that I did when I started working on Julia. I remember I was taking my course on Julia with parallel programming, and I wrote my first multi-threaded code, and it crashed. There was false sharing happening, race conditions happening. There was so many things happening that I couldn't understand. So I thought, let's take a pitch on this and work on what challenges people like me who don't know anything about Julia face. So this is me sitting, okay, guys? This is me sitting between Julia and multi-threading, trying to figure out that what am I writing. So as a novice developer, as somebody who start, we need to know that how the syntax is working, how to remove the race condition, how to check where is the memory allocation happening. So all these challenges that people face while they're writing code I have described over there. So this was done using a qualitative content analysis approach. I'm sorry if you haven't heard it before, because this is usually used in HCI, that is human-computer interaction. So why did I choose this was to try to have an in-depth understanding of how people use Julia for multi-threading. It was cost-effective. I didn't have to buy any software because it was all manually done by me. I had to read all the Julia discourse questions, all the Stack Overflow questions to understand what people are trying to write. So I did that, I'm sorry. And I have identified some patterns and themes from this data and also understood what psychology people have behind asking these questions. So the findings. So these were the 5 themes that I had. Theme 1 were how people were tagging the questions. They didn't know how to do this thing, and then what I expected and what was the reality. And the fourth theme was difference of platform usage. So just a quick heads up, I have actually compared Julia Discourse and Stack Overflow somewhere or the other. And the last was what difficulty they face. Before I move towards stats, this was some statistical data. So I saw that obviously performance issues always rise in multi-threading support. So people ask questions about that. But the interesting fact was that people inquired about a lot of things that they were not able to get in official documentation. So they had a lot of questions and inquiries about different topics that I'll be discussing in the next slide. And then when we got that we had performance issues, we tried to figure it out that what were the causes behind them. For example, here we saw that memory allocation playing a great part. So at today's keynote speaking thing, when they just skipped the multi-threading support part, I felt bad. So it was quite hurtful that they haven't talked about how, they have talked about garbage collection, they have improved it. So this study was way before that version that they are going to release. So these were some of the issues that people faced, like they were mistaken by how to use the macros, how memory is being allocated, how global variables work. So these were all the causes that we find behind slow performance. Well, this was a topic that I just said that people ask about good practices, whether their code is correct or not, how to switch between multi-threading on and off, which was quite interesting to know that people do ask about that. And testing and debugging was not part of that, which was quite what was not expected, that we were thinking that people would be asking about how to test their code, how to debug their code, but nobody asked. So the other pie chart that you can see is we have compared Stack Overflow and Julia Discourse. There were fewer posts on Stack Overflow as compared to Julia Discourse, but the interesting fact is all of them were solved. And there were none which were not like, there were very few that were solved, but they were not being reported as solved. So this is, I think, which is whether there's a change and there's a maintenance change needed in Julia Discourse. So just taking a elaborating the themes. So the first theme was, where should I tag this? And I saw a lot of posts, people actually tagging multi-threading and meta programming, distributed programming under the same tag called multi-threading, which it is not. I'm sorry. And then it was important to know that when people tag these posts under the wrong tag, it can lead to wrong audience, and it can you can't get the answer. They're not able to solve it for you. So this may confuse the participant and the discussion forum, which is helping you out. The next was, how do I do this? So here we'll be talking about something that everybody has talked already. That was on the survey as well, that people have some issues with the official documentation. They find it very unclear. They try to inquire about these concepts using minimum work examples. They want to know that how this concept has been done, and if there could be a working example to explain that. Also, I have seen that various performance tips have been provided by Julia before writing a multi-threaded code, but nobody takes them into account while writing them. So it's a problem. So these were some of the posts that we found where people have written about this thing. That one of the posts you can see that I'm sure the elegant answer is in the documentation, but I am not able to find it. And then we have also seen that I have read the documents and many topics in the discourse, but I'm still not sure if I'm doing it right. So these were some of the posts that we find, and we have seen people inquiring about various concepts. The third theme was expectation versus reality. So while I was conducting this research, I saw a lot of papers on debugging and testing. So we use it for multi-threading. I was expecting a lot of questions on that, but didn't get any, just like one question in the whole multi-threaded tag. And then we saw that we have read that atomic operations are used for avoiding race conditions, but they are not being suggested by developers on the discourse because they impact the performance of the code in a very different and a bad way. So developers expect Julia to behave same. I have seen today that people comparing R, Stata, Julia. This is what we saw for multi-threading as well, that people try to compare the performances from different platforms with Julia, which was quite interesting aspect. Somebody just told that Chapel, I think Chapel works better. So there are many things that have people said on the discourse. So yeah, so this is what people have told on discourse, some of the examples with that. Moving forward, comparing Stack Overflow and Julia Discourse, as I said, Stack Overflow tend to have more solved posts. Maybe this is because Stack Overflow is encouraging in the factor that they have badges, they have maintainers, they are just motivating the potential developers to come and just solve their issues and just to talk on something. I think we can do it as well in a very good way, that we can have an organized way for Julia Discourse. We can have people who can maintain the post and then something to encourage the developers to come and solve the issues. Then we had some the theme 5 difficulty, where most of the race conditions were happening, which was due to the lack of knowledge of scope of variables. Then we found that people are confused about memory model of Julia, which was also explained today in a keynote speaking, that the memory model issue has not been still solved. Some features and usage factors of macros is not clearly documented. So, well, I think this needs to be done. So this is some of the examples with that. I'm sorry for not explaining. So this is some of the future recommendations that we found, that we can improve our official documentation. We can also improve some features and the usage of macros with proper minimum, with the example, and to be clearly documented. There are some novice developers confused with the usage of atomic operations while they're working on threads. Memory model of Julia is still, they need more clarity about that, how the threads are being accessed over there. And then maintenance of Julia Discourse needs some more encouragement to engage higher audience, because I think Julia, it is that Julia has a potential to reach the highest platform it can. So this was everything that I had for this small talk. Thank you so much to everyone. Thank you so much to UNB and Julia community for giving me the opportunity to present here. Thank you so much.
Thank you, Harshita, for the interesting talk.
Any questions? Hi, Stephen.
Just 1 or 2 questions.
Yes, sir. It's like I did everything by myself. Manually, no software. I had to read every post by myself and just put it into words and then do the statistical analysis on that. So yeah, it was a lot of work. So he has, so he has a question if I have a published paper or not. So fortunately, I just completed this study last month, and I'm looking forward to maybe publish this as a paper so that people can have knowledge from this. So it could be a chance. Thank you so much to everyone, and
Thank you.
Okay, now we'll have the Julia Gender Inclusive Birds of Feather. If you want to participate, please stay in the room. Can I start? Oh, thank you, people that stay in the room for the Julia Gender Inclusive Birds of Feather. We will get started. It's a great pleasure to be here to guide the discussions and bring some topics to the table. Due to the Julia community spirit and vibes, and also what we can do to make it better and more welcoming for everybody. So this is a session for you to share your thoughts, your concerns, also bring us things that you like about Julia, things that you think are good in the community, and things you think are not that good. We will have a moderator, Huda. So she will guide and moderate the answers, replies, and everybody's comments. And we'll have a notes taker, Jacob. So all the discussions will be registered, and we will make our best to implement these changes and try to work to make our community better. So I think Huda will say a little bit about the moderation rules. I think it's turned off.
Okay, now? Yeah, okay. Hi, everyone. Thank you for being here. So I'm just going to, really, Leticia will be running the session. I'm just going to be here for support and moderating between just making sure everyone gets their chance to talk and also just being a timekeeper, essentially. So we'll have just a few guidelines. First of all, if you're speaking, if you could limit whatever you're saying to like a minute and a half, a maximum. We want to try and have everyone share their thoughts and opinions. So that's just on a personal topic level. If you're speaking for the first time, if you don't mind just introducing yourself, saying who you are, what's your background, something about yourself, just so that we know who you are. We're going to also try, I think Leticia on the next slide will share a few topics and ideas and things to talk about. So we don't want to talk about the same topic for the 60 minutes, so we're going to try to switch gears every 10 to 15 minutes, depending. There's going to be a little bit of personal judgment, so really every 10 to 15 minutes we're going to try to switch to a different topic. If no one wants to change the topic, sure, we can keep talking about the same thing, but we just don't want to end up talking about the same thing for basically running in circles. So that's really just the guidelines. I'll try to move around, give the mic to people. If you want to talk, just raise your hand and we'll get to you. And with that, Leticia, you can start with them.
Okay, thank you. So I brought some topics to begin the discussion, but everybody is welcome to bring topics as well, because we might be missing something here. So to start with good things, let's talk about our favorite things about Julia. So who would like to start saying something? So if nobody wants to start, I would like to talk about one of my favorite things in Julia. It's the multiple dispatch, of course, because I directly use it in my work and the production of my packages. For those who don't know me, I develop quantum chemistry code, I work with computational chemistry, and I'm trying to develop code that accelerate electronic structuring methods. So I use multiple dispatch to do that. And I would like to ask you, what are your favorite packages? What do you more use in your day-to-day work? So no thoughts about it? Yeah, let's move forward. So let's talk about the Julia community then, because I think at the end of the story, that's why we are here at this Birds of Feather. What have been your experiences with the Julia community in general and with respect to the gender diversity? If you have a story you like to share, even good or bad, you are welcome to take the microphone and speak a little bit about your experience. Oh, okay, great. Thank you.
Hi, my name's Rebecca. I am actually not a developer. I am the manager of operations and HR director for a small company in Michigan called Great Lakes Consulting Services. We're actually a preferred partner of Julia Hub. I love the Julia community. One challenge I have as an employer and an HR representative is this conference is the first time I've met another female Julia person. So I came here today hoping to find suggestions on where I can find more of you.
Oh, thank you so much for sharing your experience. It's good to hear from people that are not developers what they think about Julia and the Julia community. So thank you so much. I would like to ask, and you can raise your hand, who is in their first JuliaCon? Oh, mostly everybody. For those who are frequent attendants, I would like to ask if you have a story from previous JuliaCons to share with us also. It's my first JuliaCon as well, so I don't have stories to share. But within the Julia community topic, still, is there anyone else that would like to share their experience in Julia Discourse, for example, something you faced on Slack or situations that you might think it's important to share with others? Oh, okay. Yes, great, thank you.
So I'm Rachel Kirchen. I'm a computational material scientist at Carnegie Mellon. I've been using Julia since, I guess, late 2019. So this is my first in-person JuliaCon, which is awesome. What I was going to say is my personal experience with the Julia community has been tremendously positive. So I came through a physics education, which is a very kind of notoriously male-dominated field, and actually had overall a good experience there too. I mean, there were bumps in the road, but I know people who have had much worse experiences than I have in that community. Julia has been like a tremendously helpful, supportive, friendly community in my experience. Of course, I do not say this at all to, minimize if anyone has had other experiences, but in my experience, it's been tremendous. It's a thing that I tell people about the language. Like, you can post on Slack or Discourse and people will be friendly and helpful, and sometimes it will be the literal developer of the package you're using or someone who is a core developer of the language who helps you out, and that's just like really, really cool. I think it's certainly the lack of diversity insofar as I've experienced has just been as like kind of a bummer. Like they're just like, it's like it's not sort of an explicit thing where I feel discriminated against. I feel like a little bit lonely, and that's kind of like a bummer. And I would definitely love it if it were more diverse, obviously in all kinds of ways. But at least it's a testament to the community broadly that my personal experience has been very, very positive. That's all I wanted to say there.
Great, thank you.
Have you got Slack on your computer? Sorry? Have you got Slack on your computer that you can put on there? Yes. Can you go to the community channel and scroll to the top? Oh, and do I have to use the mic? Are we recording or like it? Oh, I don't know. We are recording, okay.
Please use the microphone for sake of accessibility for the deaf.
Oh, okay then, yeah. That's fair.
Yeah. Do you still want me to?
I mean, yeah, we can do this. I just.
Oh, okay. I'm just trying to reconnect because I think a lot of people are using the same network and we have this issue. But I should be able to.
I guess my concern with recording is more that like people might not entirely feel confident to share things. So
yeah,
it might be a good idea not to. Yeah.
I'm sorry about this.
Yeah. Okay.
Yeah. So yes.
Okay,
Great.
Yeah.
Yes, I have the community Slack.
Yes, it's you, yes. Yes. Can't hear me whispering either.
Okay, so we stopped recording? Oh, okay. So,
Okay. I mean, it's okay for me, but yeah.
Okay.
We can continue.
Great.
So scroll to the top, please.
This?
No, up to the top, very top.
Oh my God.
And a little bit down. Yes, this has not been lost in the Slack yet. So I just wanted to show people that I came out on Slack as trans, and this is what happened. And I also announced a technical thing on Slack, and that's what happened. And if you, and so I think we can see that by the number of reactions, coming out one. So I guess that was a very positive experience. I don't know if I had anything else to add to that particular one.
Yeah, thank you so much for sharing your experience. Thanks, Professor Kerching, as well. So who else would like to share experience, situations? Feel free. Yes, Frames.
Hi, Frames, she, her.
Thank you so much.
I think one of my first interactions with Julia community was on GitHub a very long time ago now. It was my first PR, and I was like a baby developer who didn't really understand Git. And someone told me to squash my PR so it could be merged. I was like, I don't understand any of these words. And Katie Hyatt offered to, I think, jump on a video call with me to show how it was done. Because baby developer, no idea what these words even mean. And I don't remember if she actually did, but just having that interaction of someone willing to take the time out of their day
Questions?
All right, shall we get started? Valentin, also ready? Still talking. Anyways, I'll just start talking. Hello, everyone. Welcome. My name is Carsten Bauer. This is Valentin Shiravi. And this is the Julia for HPC Birds of Feather session. So Rust is over, and now is Julia again. And yeah, so basically it's an in-person realization of our monthly HPC call, right? Because we have the fourth week of the month, and the day is slightly off. Typically we meet at Tuesday evening, at least it's evening for me. I don't know what it is in the US. And 3 p.m. or something. So let me first start with that, right? If you want to contact us or get in touch, the typical channels are the Julia Slack or the just aforementioned monthly meeting. You can find the date also on the community calendar on julialang.org. So yeah, that's that. And we want to kick things off. Obviously, there's going to be a discussive format. Yesterday, we had our mini symposium with lots of great talks. And today, it's mostly about you, right? Topics, also complaints, right? We love complaints. Also GPU complaints. Katie, I don't know where you are, but they are welcome. All right, but as I said yesterday, we, in the mini symposium already, we always want to conduct like a little Julia HPC survey, which we want to use to sort of first of all get a feel for where our community is at, like where are you computing, how large scale are we running simulations, all these kinds of good questions. And we want to track that over time. So we ran that for the first time last year, both at JuliaCon and Supercomputing, and we ran it yesterday in the mini symposium. Feel free to fill it out if you haven't done so yet. Don't fill it out if you filled it out yesterday, so we don't make us more work in a way. All right, I guess that's it for now. And we wanted to kick things off by collecting topics that we want to talk about. So the idea is that you approach these or those.
Yes, please find a blackboard.
Please find a blackboard if you want.
What's it called?
Chalk.
Yes, chalk on them. And if you have a topic that you want to bring up, a topic of
Yeah.
discussion, write it in readable font.
Yeah, and it's about topics, right? Not a one-page question, right? Like topics, and then afterwards we will basically vote by hand which we find most important, and then select the top 5, and then talk about those afterwards.
Yeah.
Anything more?
No, that's it.
So get going, please, guys. I know that some of you already have ideas. Feel free to write them down.
No heckling during the idea generation phase.
I'll leave it to them.
And everybody should feel empowered to do so. We're gathering ideas about the topic. Okay.
Write it down.
Yes.
Somewhere.
Absolutely. You're not one of the organizers, but even the organizers are writing things down.
Yeah, it's great. Keep it to you. It's for the audience.
Yeah.
Go
I'm going to keep the boards open for another 3 minutes, or when everybody sits down.
Is that the same survey as yesterday?
Yes.
Yeah. Don't do it again if you already.
I won't disturb the results.
Want to write something down? We should also take pictures, right? Also of the topics that we don't.
Yeah. I think everybody is not gonna use a stick to touch that topic, because then the entire buff is gone.
There's
Oops, I'm sorry. Nice presentation. I just have to skip the last part. I've seen it before.
Oh, yeah. Nice to meet you in person.
Yeah.
Yeah, I'm gonna start documenting.
Do you do the voting or? All right. So we will do the hand voting in a second. It seems like everyone has. Sorry, guys. Seems like everyone has put the topics down. Okay, one more person. We'll do the hand voting in a second. We will take pictures of all of these because we also want to address some of these points that we won't be able to cover today, right, in the limited time frame. So maybe some of the stuff we can discuss in, I already read documentation, right, so maybe some of that can be addressed offline afterwards.
Or we can pick them up for the August monthly call.
Or for the next monthly call, right, we have a HackMD there with agenda, so maybe we can talk about those over there. Right, but now the voting, Valentin?
Yes, so we need to do a little bit of clustering. Does anybody have a good clustering algorithm that works in parallel?
Yes, documentation and stuff, that's definitely...
We just point and people raise hands.
No, but first we want to cluster, like maybe the duplicate points, I don't know.
We could also cluster after.
I see there are some points about distributed. There is mine, how to make it faster. There is a distributed user base too, which I think is related.
The next buff will be distributed. We're going to have the distributed buff at 4. Yeah.
Distributed.
Then documentation and community.
I guess anything related to tracing and debugging could be like
Tools.
Something else mentioned, apart from tracing?
Julia, I mean, a lot of tooling, right?
Okay.
I think if we did like a platform weirdness cluster would be like distributed file system, weird architecture, new everything.
Julia at HPC centers.
Yeah, that's good.
But I do think that distributed file systems could be like a cluster in itself. It's a big subject.
No, yeah, there's a bunch of issues just with that.
Then I think one is performance. Performance and latency.
There's one about deployment on HPC. I guess like includes documentation. I guess, right?
Latency. 1 point. Would make it a separate point. It's a different number.
There's some kids.
GPUs.
Maybe one just like deployment, because this would be like Julia over there, and there's like the convention university, and then there's all kinds of deployment.
Yeah, and then do deployment.
Where does mixed precision fit? Because there is one about mixed precision there.
Maybe here.
Decisions. Is that the thing, I guess, I don't know.
Features. Cogen or something.
I want to get to know the audience a little bit. How many of you are running Julia on HPC clusters today? So, no. So they're familiar with a lot of it.
Something not captured. I mean, we can always fall back to the individual points, but just for the voting, that's best to group it.
Sounds good. I think. Do we have tracing tools? Trace what?
There's tools. I made a generic point.
Okay.
I can, yeah, okay. Tracing API.
I'd be interested in a quick survey of like which supercomputers everybody's on.
Well, do we have access to the live data of the survey?
Yes. What do you want to know? Because
You got the table on the paper.
Which clusters people are running?
Yeah, I checked it yesterday evening, so it's modulus, the people that filled it out right now. From top of my head, NERSC multiple times, ONL was mentioned, lots of clusters in Germany, like Gießen, Paderborn, Jülich, Halle, Stuttgart, for those who are aware. In the US, it
Can we
was
just quickly
also
survey the room? Who's at NERSC?
Who's running coded NERSC? 4, 5.
RNL? 3, 4, 5 people. Weird German clusters. Normal German clusters?
So, yeah, and NSF clusters.
any cluster that hasn't been mentioned before.
Yeah.
This is helpful context.
Yeah, yeah. There is a paper we put on archive. It has a table with different centers. That was
Oh yeah.
yeah.
Yes, Switzerland. Guzan Lumi.
Finland.
Yeah, sorry, yeah.
So
I'm confused
what?
because I'm always connected to you guys, right? Ludovic and you, so that's.
So one of the reviewers in our rejected tutorial supercomputer was like, "No one uses Julia on my new university cluster, therefore it's not important." So that's why it's good to have a sense here.
I also realized we don't need the microphones because it's not recorded or live streamed either.
Oh, so this guy.
It took me a while, but.
I don't know if the AV person in the background agrees.
Oh, like the call was that it's neither recorded nor streamed because it should be private. So that was the call up front. So I mean, you can still use the mic, but it should not go online. That was the deal, and I'd like to have it like that because we want to have an open space where everyone can say what they think without having it on YouTube afterwards. So yeah. All right.
Okay. So who wants to talk about distributed.gl? Show of hands. There's 5, 4?
Like, let's say 5-ish.
Who wants to talk about documentation, community building?
Education.
1, 2, 3, 4, 6, 7, 8, 9, 10, 11.
Let's call it 10.
11, 12.
Yeah, okay, 10-ish. Go with that.
Who is interested in tools, tracing? Okay, that's many.
I'm not counting. It's lots. Yeah, or many, whatever. Okay.
Who is interested in weird architectures, challenges of running Julias at HPC centers? 15.
Slightly less. Yeah. Okay. So okay, 15 is less than many.
Yeah. 15 is countable. Many is incountable.
Absolutely.
Who wants to talk about performance?
All right. This is better. All right. So first of two, Theo and Cedric will be in between my two talks here today. Two completely different subjects. The first one, I'm going to talk a little bit about GitLab, CI processes, something that is very near and dear to my heart. So yeah, let's dive into it. Who here likes GitLab or uses it? Let's put it that way. You don't have to like it. Just if you don't like it, then why? I don't understand. All right. So I quite like it as well. Just to give a bit of feedback, right? So talking about CI processes, these things are, we have pretty good CI setups for Julia. There's a lot of GitHub actions and stuff like that. Why do GitLab and why should we trust you to build these types of things for us? Well, as you may have noticed, right, I've been using GitLab for a while. I'm very proud of my 4-digit user ID. You can't get those anymore. Same thing for Julia. I've been doing Julia, or not doing Julia. I've been writing Julia code since 2014, and basically building CI systems for Julia that same amount of time, done in Jenkins, GitLab, BuildKite, GitHub. That's probably about it. So yeah, I've done this before. Also the GitLab CI processes, and I found some patterns that work really well. So I decided to implement those again, but now out in the open source system. So why not something else, right? So like, well, I don't really care, right? I like GitLab. I want this to work on GitLab, so I tried a lot of the other things. Some of the approaches that I'm taking here are just fundamentally not possible on something like GitHub. They put restrictions on things like reusable workflows and things like that just make this very hard, if not impossible, to do. So yeah, you can really make these nice composable workflows, right? Reusable CI steps, that works pretty well. I want a complete process, though. I set up tons of packages, CI for tons of packages every single day. Well, maybe not every single day, but these GitHub action steps, they're nice, but you basically end up copy-pasting your setups everywhere. I don't want that. I want a single, well-versioned process that I can just, include with hopefully a couple of lines of code and just run it everywhere. And whenever I change my mind about how the process should work, I update the process, automatically update everything that depends on it, and everything is in sync again. No more, oh, I thought I had fixed this in this one repository, but it's not fixed in this other repository. Why is it not releasing? Right, I see Venkatesh Prasad goes, oh yeah, I know that. So that's why I want a complete process. So for that reason, I started the Ethema organization on GitLab. It's not just about Julia. It's actually a couple of composed different processes that sort of culminate. Julia is one of the highest level processes that I have. This includes just general GitLab CI processes. For instance, right, so these pipelines or these processes are implemented in YAML files, right? They're hosted on GitLab themselves. So these are obviously, right, you're dogfooding your own stuff. So these processes are managed using the processes themselves. So you get processception. All right. There are a couple of principles that I sort of base these processes on when I built them. They have to be semantically versioned. We don't really do like incremental upgrades right now. It's so that you can depend on version 3 and then we'll just not break. Well, right, you can't really upgrade automatically. Every single process is semantically versioned. So if it's not a major breaking version, it's typically safe to just upgrade. You should be able to use what you need, no more, no less. We adopt convention over configuration because less configuration is more better. I know that's wrong, but it's okay. But it still needs to be configurable. And obviously, as I said, right, these Ethema processes are managed by the Ethema processes themselves, so we're dogfooding our own stuff. So as soon as something breaks, trust me, I'm the first one to know, because I probably merged it, and I'm probably then the first one whose work also breaks. And it should be easily extensible. So when I talk about use what you need, no more, no less, there are actually two different ways of using this. I've briefly discussed that it's a complete process, but each of the individual jobs that are inside these processes can actually be, used on their own as well. I need to go faster. So what do you get? Semantic release. If you're not using semantic release, you should. If you want to know what it is, watch my talk about it 2 years ago at JuliaCon, which was online at the time. It's amazing. Use it. Been doing it for a decade. Don't want to do anything else anymore. Well, obviously, you get tests with reporting in GitLab CI, so you get nice test overviews of all the tests that ran. There's like this tests section where you can see all the assertions that ran. You get a bit of dependency management, including managing the dependencies of the processes that you depend on. So it gets a bit inception-y. You get automatic version reference updates in documentation. This is something I'm incredibly proud of. Right? Typically, what you see a lot of the time is you see some documentation where something goes, install this version or install the latest version. Our documentation always just says install this version, and that version is always the most recent one, or whatever was the most recent one at the time that the documentation was written. But I never update it. It goes automatically. Obviously, coverage reports, both inline on merge requests, so you get these nice little annotations in your change logs, as well as we generate dedicated HTML reports for when it's not merge requests. Code formatting, both Julia using Julia formatter and Markdown formatting, and basically anything we can find in your repo that we can format. So how do you get into this? So just a quick show of hands. How many lines of code do you think this takes to get running? 100? Anyone? Okay, I see a few. 50? 10? 5? 0? So yeah, technically you can actually make it work with 0. I wouldn't recommend it. There is a configuration on GitLab that you can just point to a very specific external pipeline. So technically it takes 0 lines of code. I probably wouldn't do it. 4 lines of code is actually what you typically would end up doing if you just take the stuff that's right off the bat. So how do you get running? You provision a token, depending on what you want. Right? It can be access, personal access token, project access token, group access tokens. Typically, they just need API access. Sometimes they need read registry access. You can have separate tokens for all the different things. You can suffice with just one. And then this is what you do. Done. You're enrolled now. It works. You get everything for free. Well, everything that's in there currently. So what else do I want to get in there? But that's currently not in there yet. I ran a little bit out of time, so Documenter isn't in yet. That's definitely coming up very soon. When you make releases, they aren't automatically published to a registry yet. That also needs to come very soon. I'm pretty sure I can get to that very soon. I just might have to harass some of my coworkers a bit to make it possible. Matrix testing, downstream testing. Compat helper isn't in there. I actually kind of would want to prefer to use Renovate, but that means I first need to implement Julia compatibility for Renovate. There's some cool stuff going on with semgrep and Jet that I would like to put in, and there's performance perf checker that I came across this week. I wanted to do a demo, but I don't have any time. So with that, if you want to see it later, just come up and I'm happy to show you. So with that, thank you. And I just want to give a shout out to the guy sitting here, Paniotis, for helping me out with the name. Ethema means community in Greek.
All right, so for the second talk on why type instability matters with Cedric Belmont and Theo Galifayu.
Aspect ratio problem.
All right. Hi, everyone. My name is Cedric, and today I'll be with Theo to present our talk, When Type Instability Matters. So Theo and I are both working at Planning Space, and in a nutshell, what we're doing is we're building some kind of explainable answer engine where the idea is that you have a query coming in and you want to answer that query taking into account uncertainty, and so essentially returning distribution over possible answers ranked by decreasing probability. To do that, we actually synthesize a whole function in the middle. So essentially we have a query, and then we assemble a Julia function in a Julia module to be able to answer that query using different bits of knowledge that our system knows about. And then we run that probabilistically to then obtain the distribution that we want to return to the user. The idea is that then it's fully transparent, because as we synthesize a whole procedure, we can actually also return that function so that the user knows all of the steps that were needed to derive the answer. But to do that, we typically need to generate some code. We want to generate a Julia function, a Julia module. So essentially, so it's not just a single function. It's essentially we generate a bunch of types, a bunch of functions, one of which is the entry point that we run to try to answer a query. So in the code generation process, we need to think about, okay, what type of code are we going to generate? And we know about type stable code, and we know that it's a good thing, a good standard practice in Julia, because it makes things more performant. In a nutshell, it is a property of a program where the compiler can reason about intermediate values in your program and know exactly what different types these values have. Then it can do more optimizations, and it is not needed at runtime to figure out, oh, what did we actually get? It is notably named in reference to the notion of type instability, where if at some point in your program some value has an unknown type, then anything that uses that value will also have an unknown type. So it kind of have a cascading effect. So it's apparently better for performance, so why not? Let's go and use it. So first, we're going to emit a bunch of types, which would be sort of analogous to what we're doing. So here, let's say we want to answer the query, what is the coolest animal? For that, we're going to generate a bunch of animals as types. And the idea is that here we really generate types, because then we can use multiple dispatch to express the logic. So for example, we can define coolness methods on different types of animals, depending on their attributes. We can be very opinionated and choose that one animal is coolest over all the others. Why not? So then how do we go about typically kind of answering the question, what is the coolest animal? So we're going to do it maybe in a bit of a convoluted way, but it actually represents more what the kind of execution we would be doing in our probabilistic setting. So here we're going to draw a certain number of samples. So we're going to call our generated program a certain number of times. Let's say here 200 times. So essentially, it will involve drawing two random animals, in this case. Why not? Then we see which one is the coolest among those two. And then we're going to record which animal kind of won the coolness battle out of both, and just increment a counter in the dictionary. We also, why not record it in a trace? Because typically, in a probabilistic programming setting, you would record certain results of outcomes in a trace. So, okay. We can do that, and then we take the animal that won the most coolness battles. Why not to say that it is the coolest animal? So obviously we have a system where latency is very important. We don't want the user to wait for 30 seconds before having an answer to his query. So let's try the performance a bit. We see that we have about 10 seconds for just the first run, about the same for the second. For this kind of example, it's really atrocious. Most of it is compilation time. So maybe we can do something about it here. And actually, when we take a look at it, we see that we have places where we actually involve the compilation of methods where we have actually pairs of animals that need to be compiled. So here, say we have 100 types of different animals. Make it squared if you need to compile methods for possibilities of pairs of them. And we can actually see that with Snoop compile. We see that it shows up. We do indeed compile a lot of methods with these tuples or combinations going on. So now I'll hand it over to Theo and hope that we have an actual solution to solve this.
Yeah, so the first approach we can think of is to
tell the compiler, do not do that, and add a no specialized, use a no specialized macro. So the no specialized is going to tell the compiler, do not create a new function instance for each of the types you meet, just make one for this abstract type. And it doesn't help that much, as you can see. We still get around 10 seconds, and when looking on more runs, we actually get worse performance. And one of the main reasons for that is that not specialized only applies on one layer, so it will not propagate through the function that you call. So if you call not specialized on some external functions, then the next time you need to compile, the next time you call an inner function, it's going to be compiled and you get the same problem again. So on higher order functions like map, for the broadcast, you're going to get all this inner machinery, which is going to create tons of methods. And also, you cannot apply it on things you don't own, right? You cannot go onto the dictionary package and say, don't specialize that. Well, at least it's not possible right now. One solution we propose is to use a wrapper. So we basically create a struct with an inner field, beast, which represents our animal. And you can notice that this is not parameterized. We cannot know in advance what is inside the animal. But all we care about in the end is the coolness. So we only need to unwrap what's inside when we need to compute the coolness of an animal. And this is type unstable, because anytime we're going to call animal.beast, the compiler doesn't know what is inside. And it's going to, so the whole time, basically, when we're going to run our program, the compiler will just program things for animal, not knowing what's inside, and it's going to be fine. It's only when I'm going to call coolness that is going to need to unwrap it, be type unstable, but that's just one small part of the whole pipeline. So let's look at what's happening when we run our same benchmarks. On the first execution, we already get like a 15 times speedup. And you could think, okay, sure, but then you have this type instability every call. Well, actually, it's not even true, because on further runs, it's even faster. Because once we have compiled things for animal, we don't need to redo it again. We just have the performance decrease from the type instability, but which is negligible compared to all the compile time we have. So for our use case, it's especially useful. So we have thought of other cases where this happens. A typical one is the tree, where if you want something very type stable for homogeneous nodes, you would need to parameterize the children, the node based on the children, but then you would be parameterized on the children of the children, and you might end up with like this kind of massive parameterized types, for which you would need to compile a new method every time. Another case is obviously our generated type. This is kind of what we showed here. We even found another case in package.jl where there was a pull request to propose to wrap IO, which is an abstract type, and has the same issue that you need to combine all possible IO types with all possible objects that you want to print. And this creates, again, this like massive compilation overhead, which might not be necessary in package where you just care about the first run mostly. So is this bad? Yes, we do not get what we want right now. But it's only some part of the code. We showed a minimum working example for a very specific case. The rest of the code we have is at least aimed at being type stable and work. And I mean, it just shows that Julia is just very easy to control. You can have places where you have a full control over inference and you can have your static language style performance, and other places you just have the flexibility of a dynamic language. As said, we offer you have some references. And I said we're from Planning Space, so don't hesitate to talk to us about the project we are hiring. And yeah, thank you. And any questions?
Thank you. All right. I think the questions would be in the offline. So, right. So I would like to welcome Joris back. All right, take it away with your second act.
Why is this thing so big? All right, get back. All right. Hello, I'm Joris. We've met before. Now for something completely different. Nothing related to GitLab, apart from, well, that's where I am on GitLab. This is all, and that's where the package is hosted as well, obviously. Right now, I want to talk to you about a new package that I made. Well, I'm saying new. We'll get to that in a bit. But it's a package that's meant to be able to make it easier to declaratively impose constraints upon values. Well, done and talk. So some motivations and a tiny bit of history. So this package has been something that's been on my mind for, I don't even know how long anymore. I've wanted to write this for a long time. It's still not done, unfortunately. And I finally got started on an actual implement. So I've been wanting to talk about this at JuliaCon for, I don't know, since 2018 probably. Finally got started on in 2021, December. Been building some prototypes on top of it. And it's in general as of an hour ago. Yes. So there will be a bit of focus on web development because that tends to be what I do. I think in general it holds a bit more. It's a bit more generally applicable, but so don't be put off by the focus on JSON and stuff like that. So when I'm building applications with separate front end and back ends, I typically require a lot of duplications, right? I have constraints on code in my back end or on types on my back end, then I need to replicate that in the front end because I want my inputs to have like validation and stuff like that. It's just annoying. I need to copy data structures around, impose validations on those structures, etc. Now, obviously, we have tools like JSON schema, right, which are technology-independent ways of describing structure on data, describing constraints on whatever fields are in there, on elements of arrays, stuff like that. This is something that gets used in higher level, right? If for us that don't know, right, OpenAPI is sort of a superset of JSON schema. There's this other cool thing that I recently found called async API. You have GraphQL. There's tons of these things, and they're also, as I said, right, not necessarily specific to JSON. Now, for these types of things, we have quite a few solutions in our ecosystem to read these specifications, but I have one big problem. I don't want to write them. I'm not sure if anyone has ever written an OpenAPI spec by hand. It's sadness-inducing. Yeah, it doesn't really make you happy. Plus, in a lot of cases, then when you have that spec, you can generate it, but you still need to fill out the handlers anyway. So what I'd rather do when I'm writing an HTTP server, I write my handlers, I have my router that has like 95% of all the information that I need. What if I could just run some code on it, get the spec out that I can then send over to my front end? Spoiler alert, that's not in this talk, but you can do it. I've done it. Enter. Oh yeah, well, but a lot of the metadata we need for that is already available, but not everything, so enter value constraints. So what is value constraints? It's a framework. I call everything a framework, or a platform. Depends on what level it's at, for declaratively specifying constraints and applying them to values. Well, what gave it away in the title? So what does it give you? It gives us currently a standard library of some very common constraints, right? Think minimum, maximum, multiple of, needs to be in this set, needs to be of that type, blah, 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 blah. One thing I personally find really important is it gives you nice error messages. Instead of, assert failed, like, okay, and then what? I don't know what to do with that. You can obviously, right, you can have compound constraints. You can do things like, I want all of these constraints to be true. I want one of them to be true. I want exactly 5 out of 6 of these to be true. You can do all sorts of stuff. When we're talking about these OpenAPI specs and these async specs and JSON schemas, they need to be introspectable, because if they're introspectable, that means I can generate these specifications. This is the core reason for doing this. They're serializable and deserializable, typically through struct types, which is an awesome package which primarily integrates with JSON. I'm hoping it also integrates with the new version of JSON, which is not JSON 4, I don't know. And it's fast, right, when you're evaluating it. This was a major stumbling block in the beginning, so I actually have a bunch of benchmarks. If you look at the repository, there's a bunch of benchmarks in there to make sure that it's actually as fast as if you would be writing like regular function calls. There's no difference. Not in allocations, not in speed, it's just the exact same thing. And what I also like is that they are, right, once you have written down one of those constraints, are actually reusable. You can just apply them later to different, oh, I'm making good time on this one. Whew, maybe I'll go back to the other talk. So, right, so you can, they're also shareable in this case, right? So if you have a specific type of constraint that you want to apply to multiple values across the system that you have, you just store them in a variable, and then you reuse them across wherever you need them. So let's take a look at what it looks like. Everything has capitals because they're constructors. Fight me, I guess. So one of the things that is in the common library or in the standard library is minimum. So we stick it into a variable, and then we can call that thing with whatever value we want, and it will tell us whether it's valid or not. Right, 10 is more than 5, 1 is not. Now this is, right, that approach can't error, right? It just tells you true or false. So we can also call isValid on these and then pass the value as a second argument to that, which still does the same thing by default. But if you pass fatal, it errors. And look, nice error message. It actually is very friendly and says 3 should be larger than or equal to 5. As I said, the same thing we can do for compound constraints. So if I add a second one, call it multiple of 5, I combine them and I say I want all of these to be true, I can call isValid minimum and multiple 10. Well, apparently that is. And again, if it's not, nice error messages. Ooh, where did the n come from? It's not supposed to be there. So what you might notice is that actually it even pulls out the one that it's not valid, and then it's nice. This took way too much effort. And in this case, right, neither one of them are true. So it actually says that like one out of these 2 constraints should have been true, and one of them, and they're not. To be able to work with validations on primitive types, right, you can't really change them or validate them that easily. Or especially if you want to change them over time, right, which is the thing if you have like an integer in your REST API somewhere and you want to validate it every time it gets updated. I've added a very simple container type. You just stick a number in there, or stick a value in there, stick your constraints in there. When you try to construct it, well, if it's not true, it errors. You can set that same fatal flag to false, then it actually just goes through just fine, but as soon as you call isValid on it, it goes nope. You can push new values into it, like using the useful, what is it? I always call it dereferencing. It's not, but you can also just write to the value field. Same thing happens. Yeah, those are all the demos that I have. Some people might, I guess you can think, aren't there similar efforts? Well, yeah. Honestly, I haven't looked too deeply into them. I just wanted to write this thing. Right, you have, obviously, there's Julia constraints and Jump uses constraints, but at least in my, or at least as far as I know, they serve a slightly different purpose. So I'm not sure how, I briefly looked at them and it didn't jump out at me like, oh, I can do this thing that I want with them. There is another package by someone who I used to work with, designed by contract, which is actually pretty neat. It's for putting contracts on method signatures, which I kind of like, and I think we could actually do it with this. So this is my roadmap. Documentation, I'm sorry. It's this talk serves as a documentation for now. Some things I would like to implement, come help me hack on it tomorrow if you want to, is constraint structs. I think would be a cool idea. Same thing for constraint methods, and then being able to actually take these values, right? If you have a bunch of these composed constraints, turn them into schemas. I have some prototypes for it, but it's not in the package right now. So just some quick syntax. This is what I think the constraint structs stuff could look like, right? So we'll have a macro that extracts this additional type information out, and then you just get your struct back, and then we'll automatically generate like the set property and stuff like that. Methods, not sure yet. This looks a bit overwhelming, but yeah, actually it doesn't look half bad. So yeah, thank you, and especially to everybody who's listened to me drone on about this for years and years and years.
Okay. So the last talk is a 30-minute talk by Jorge Perez Hernandez, Luis Eduardo Ramirez, and Luis Bennett on neos.jail.
Thank you, everyone. So yeah, we're going to talk about some research that we published last year on near-Earth asteroids and the Julia package that we developed for this purpose. This work has been done in collaboration with my former PhD advisor, Luis Benet, and also Luis Eduardo Ramirez Montoya, who's going to talk to you about some orbit determination methods. So just what are near-Earth objects? So in general, near-Earth objects are essentially asteroids, which can come very close to the Earth. So that's different from main belt asteroids. This one's better? Okay, so, okay. So what are near-Earth objects? So near-Earth objects are essentially asteroids or comets which can come very close to the Earth. That is in opposition to main belt asteroids. So and they are leftovers from the inner solar system formation process. And astronomical surveys have been very successful at discovering asteroids. And the sooner they're found, the better. So essentially the name of the game is find them before they find us, right? And then even so, there are still some issues because we have some observational bias towards the outer parts of the solar system. So we should map better the inner parts of the solar system to get a better situational awareness of how all the near-Earth asteroids population is composed. So what I'm showing there is an animation from the NEO-WISE data. So what you see in gray is just main belt asteroids discovered by that mission. And the dots in green are near-Earth asteroids. So those are the asteroids that are either completely into the Earth's orbit, or they can also cross the Earth's orbit that eventually can impact it. Okay, so we have here, if we had a perfect knowledge of an orbit state at a given time, then we could predict with perfection how they are going to behave in the future, and either predict if they are going to impact the Earth or not. But in reality, we have uncertainties from observational models, and also from force parameters that come into the dynamical models, right? So we have to be very careful when propagating these orbits, and also the orbital uncertainties. So that's where package enters, right? So we developed this basing on Taylor integration, which allows very high accuracy orbital propagation, and also allows us to do simultaneously two Taylor series expansions, and we call that jet transport. So we use one Taylor expansion to propagate in time, and we use the second Taylor expansion to keep track of small variations with respect to the initial conditions. And we are able to perform orbit determination using optical and radar astrometry. And also we are able now to do preliminary orbit determination using Gauss method. And so what is jet transport? Jet transport is what I was telling before. It's a way to keep track of, for example, if we have a nominal or reference initial condition, say x0, and we have small perturbations to that reference initial condition, then we can keep track of it as in terms of a truncated polynomial algebra. So we treat this perturbed initial condition as a vector of Taylor ends of float 64 in Taylor series in Julia. And that allows us to keep track of how this neighborhood around the reference initial condition deforms in time. Okay, so what I want to say here is just that using several packages from throughout the Julia ecosystem of packages, we have been able to
to ingest into our neos.jl all the information that we need and do all the statistical treatments that we have to do on optical astrometry, for example, and also do all these transformations between the different frames that we can define with respect to the Earth. And for that, we use in particular satellite toolbox transformations. And then, for example, for our optimization procedure, that is finding the minimum that we can find in the mean square residual function, which is our loss function, we can essentially treat our loss function as a Taylor polynomial in the perturbations of the reference orbit, and then we can minimize that, and then it's very straightforward to find the best candidate, right? And then in particular, I want to talk about asteroid Apophis. So it was discovered in 2004. It has a diameter of about 400 meters. And just 2 days after being discovered in June 2004, it was lost, and it was recovered until December 2004. And around the late December 2004, the impact probability for the date on Friday, April 13th, 2029, reached a maximum of 3%. So that's a record to this date, and to this date, Apophis is said to be the poster child of near-Earth objects, just because it surprised the astronomical community when it was discovered, right? So just to show you how the situation was, we prepared this little widget. So what you're seeing here is the target plane for the impact in 2029. So the black circle is just the Earth's cross-section in this plane. And if the actual orbit of the asteroid goes into this circle, then we have an impact, right? And we have what we see in in green is the uncertainty region. So what we had in the beginning, in around early December 2004, was just this a huge uncertainty region, right? Which we couldn't say that an impact in 2029 was impossible. But as we got more and more and more observations, then that's how we discarded an impact in 2029. But the problem is that even though we discarded the impact for 2029, there was still a possibility of impact in, for example, 2036 and 2068, which are represented by these arcs, the circles, the purple and the blue circles. So for example, if the actual orbit in 2029 should pass, for example, around this area, then we would have an impact in 2036 and the same for 2068, right? But then what we did was precisely, okay, so that's just a video of the same thing that I was telling you guys. So what we did was take even more data up to from 2004 up to 2021, and so this is the actual situation that we will have in 2029. So we won't have an impact, but it will come pretty close. Actually, it will come. It will intersect some satellites' orbit. So yeah, it's a near miss just by very little. And indeed, the question remained open up until very recently of whether we would have an impact later on, right? So, for example, what we did with our orbital fit to Apophis was that if we take into account only gravitational effects, then we cannot fit all the orbital astrometry, all the optical astrometry. But if we take into account also non-gravitational effects, such as the Yarkovsky effect, which is similar to solar radiation pressure, right? It's a radiative effect, and if we take that into account, then we can indeed fit all the optical astrometry, and we have the residuals behaving as a Gaussian. So, yeah, we don't have any systematics going on in there. And then, for example, to fit the radar astrometry, that's very, very difficult to make because we have very high fractional precisions. And for example, a nice application of automatic differentiation that our package allows. It's just that, for example, if we know that the time delays from radar and the Doppler shifts are related by this differential relation. And using our 80 setup, then we can compute the Doppler shifts just straightforward, and we don't need any special things around going on. And then what we found here as well is that using only gravitational effects, we cannot fit all the astrometry. But if we take into account the Yarkovsky effect, then we can indeed fit all the data, both optical and radar. Okay, so what about the impact for later dates after 2029? So what we see here is the orbital uncertainty distribution plotted with respect to a variable which we call zeta, but it's essentially the orbital uncertainty distribution. And what we knew before 2021 was just this, the blue distribution. And after incorporating observational data up to 2021, then we obtained the orange distribution, and then these lines, which represent the little arcs that I was showing before for a possibility of impact in 2036 and 2068, which are called the gravitational keyholes. We see that after incorporating astrometry from up until 2021, then these later impacts become impossible. And a full impact assessment of Apophis done by JPL, for example, shows that we know that Apophis won't impact the Earth in 200 years at least. After that, we don't know, but we are going to need more data for that. Okay, so now about the preliminary orbit determination, I will leave the floor to Luis Eduardo.
Okay, so Apophis was kind of the motivating example to develop this package, but now we have two main objectives for the future. The first is what's called preliminary orbit determination, and that's being able to get an orbit directly from the observations. The most common way to do that is via Gauss method. That was developed by Gauss in the early 1800s to determine the orbit of Ceres. The method basically takes as input 3 optical observations and returns a preliminary orbit. The optical astrometry only gives us information about the angular position of an object in the sky, but we have no information about the distance. So pretty much the core of the Gauss method is deriving analytical formulas for the coefficients of an 8-degree polynomial whose solutions are the possible distances between the sun and the object. It's important that even though it's an 8-degree polynomial, it only has 4 terms, and it turns out that the polynomial can have at most 3 real positive solutions. And that's important because when we encounter multiple solutions, we have to check them all to check which one has the best fit to the data. Also, in order to give analytical formulas, Gauss method does a series of approximations that are often not good enough. So the method is often followed by a refinement step. Also, in our case, we leverage from the Taylor series .gl package, and we treat observations as jet transport variables. That means basically that instead of using floats, we use a float plus a perturbation. And we can use Taylor series to do the same process, but with jet transport perturbations. And that will give us a polynomial that depends on the perturbations, which we can propagate in time and use Newton's method to fit that polynomial to the observations that we have in that moment. The other objective that we have is automating the orbit determination process. That's basically because nowadays there are hundreds of observatories reporting new observations every day of new objects, of past objects, etc. So we would like to have a script running and analyzing all those observations. And so far we have a small script that kind of goes in that direction. We did a small run here. And basically it starts printing out some parameters. But here we applied this script to asteroid 2023 DW. This was discovered in late February of this year, just a couple of months ago. And we only have 123 observations, which is very low compared to over 9,000 observations that we have of Apophis. So the script starts by downloading all the observations available from the Minor Planet Center, which is the organization that reports all this data. Then it continues with Gauss method. In this case, you can see kind of 3 batches, and that's because this is one of those cases where Gauss method gives 3 possible solutions. So it has to check them all to see which one is the best. And here it gets to a successful set of initial conditions. After that, it can do a full integration to cover all the 123 observations and use Newton's method to fit a final orbit to the asteroid. This Q that you can see here is basically the function that we're trying to minimize in Newton's method, and well, just saves the results. So far, this script, we can specify which NEO we want to analyze, and we can do the whole process, but there's still a lot to do with this script to make it fully automatic. And finally, two interesting things. The first is that asteroid 2023 DW would get very close to Earth on Valentine's Day in 2046, as you can see in these results. The plot on the right represents the geocentric range, that is the distance between the Earth and the asteroid over this century, and the lower half is a zoom to year 2046 when the close approach is going to happen. Now, when we do Newton's method, we need a weights scheme, and that's basically to assign an orbit and observational uncertainty to each measurement. However, currently the Minor Planet Center do not give any information about the uncertainty of each observation, so we implemented a scheme published by Veres in 2017. But also other organizations like NODIS, which is based in Pisa, have other weighting schemes. And as you can see here, the different weights can give very different uncertainties, especially in a case like this with very few observations. In the last row, we have the JPL reported values for comparison. So finally, as we said, kind of the motivating example that led us to develop these packages was to determine Jarkovsky effect for Apophis and use that to rule out possible collisions in future years. Also, we've implemented Gauss's method for initial orbit determination, and we plan to implement more methods. We're interested especially in those that are specially designed for cases with very few observations or observations that are very close in time, cases where Gauss's method tends to do pretty bad. Also, by treating pretty much everything as a Taylor polynomial, we can easily do high order AD. We also have we also have a data frames extension that turns out to be really useful to filter observations, and that will be useful in the future for outlier rejection, among other things. There's still a lot of performance we can gain, especially when it comes down to cutting down allocations, because Taylor method can be quite precise, but also allocates a lot of memory, and we also have to deploy a full documentation. And among other things that we can implement are a square root information filter, systematic ranging, which is another method for initial orbit determination, to improve our dynamical models and also automate the impact assessments. So that's all. Thank you. Yeah, that's the line of sight of. Yeah, the question is, what is the white line? Yeah, that's the line of sight. The newly discovered at that point in time, the newly discovered objects at a point in time. Yeah. Yeah, exactly. Yep. Yeah. So the question is why we picked Julia, essentially, you could say. Yep, so we found many advantages of using Julia. So for one part, these high-order automatic differentiation schemes are very easy to implement and to treat in Julia. Like the language lends itself pretty easily to these kinds of schemes. And also, we didn't show all the details, but incorporating all the data sources, either from NASA, from all the international astronomical union parts, the Minor Planet Center, like all the different data sources, we have been able to incorporate them very well using all these different things that we can use in Julia. For example, artifacts. Or, for example, the Scratch.jl allows us to assimilate very different kinds of data, which that we found, right? And yeah, so there are many things and many advantages to using Julia to do this kind of analysis. Yeah. Yeah, please go ahead. Yeah. Yeah, so the question is whether these kind of techniques could be useful for Earth satellites, and the answer is yes. The only thing that you would need for that is implementing a high-order orbit propagator for Earth. Because, for example, right now we only use some of the lowest order zonal harmonics of the Earth, right? But to have a high precision orbit propagator, you would need taking into account all the higher order, zonal tesseract harmonics of the Earth, and even perhaps variations with time, etc. So that's the only thing that you need. But yeah, other than that, I mean, you can open always a pull request in neos.jl, and we could get that implemented. Yeah, for sure. It's the question is, what's the size of Apophis? It's about 400 meters. So for the curious mind, it could destroy, for example, a mid-size city. So it's not. The question the question is whether we can blow it up before it comes here. Well, it would be there's the Icarus project, which actually ran here at MIT in the 1960s. So that would be one possibility, but there are actually some other, you could say, smarter and perhaps cheaper options, which are actually being tested right now. For example, there was the DART mission from NASA, which is going to be also going hand in hand with the Hera mission, which we are going to operate at ESA. And for example, these missions, what they are trying to do is perturb the orbit of an asteroid. The sooner you can perturb the orbit, the better, so that you make the post-impact orbit be a miss rather than a hit. So yeah, but I mean, yeah, for if you were to find an asteroid with just like not seconds, okay, but maybe days of before arrival, then perhaps the options could be more nuclear, yeah. But that's precisely why it is so important to find them as soon as possible. So, yeah.
All right. So thank you very much again.
All right, thanks, everyone.